I think many portions in that aspect of science and technology will be over. So you already have an understanding of what is science and technology, what all to study in science and technology, etc. So because this is our first class, I just will briefly tell few aspects about the preparation of science and technology. From my perspective, I'll discuss a few things. Then we will go to the topics which I'll be taking for you in science and technology. So first, what I want to tell you about the subject, you will be already knowing about the subject, that this is a very dynamic subject. So for a subject like polity, you read a textbook like Lakshmikant and you will be able to answer 70 to 80% questions in the UPSC prelims. Say even economics, one standard book if you read, you will be able to answer most of the questions. See, all these four basic subjects, history, geography, polity, economics, most of the questions can be answered by reading one good standard book and revising them multiple times. This is possible because even though there are a lot of developments happening, but it is not as much as science and technology. Science and technology, every day new researches are coming out, new inventions are happening, and the subject topic itself keeps on changing. Okay, what you have to prepare for the subject keeps on changing, but there is a static core even for science and technology. There is some fundamentals which you should understand for science and technology. So this is a dynamic subject, and that is the challenge of studying a subject like science and technology. See, polity, you are feeling very comfortable with studying polity because there is already this book called Lakshmikant. So read Lakshmikant, you are done with the subject. But what to do for science and technology? You don't have a standard book. Even if you have some books, you read it, hardly any questions come from it. So how to prepare science and technology is a big dilemma for most of the students preparing the subject. Now, what most students do is read some current affairs magazines, and with that they will end their preparation. But just by reading a few current affairs magazines, you will not be able to answer the questions that come in the exam. You should know the core of the subject very well. The core should be understood, then only you can understand what is happening in the current world. So that is the missing part, because there is people mostly skip reading the core. So there are two types of again students can be categorized into two. One is the so-called engineering students. Majority of you would be engineering students. So you already have some understanding of science, right? You have studied science in some aspects. So you think science and technology is a very easy subject. You have been studying science for so many years. No, it won't. I just have to spend like 2-3 hours before the exam. Science and technology will be easy for us, which is a misconception. You will not be able to solve the problems. Second is the humanities student who feels that it is too difficult to study and let us skip it. No, we'll study all the other subjects well, but not science and technology. Let us skip it. So this is two thought process which basically comes to the mind of students about science and technology. So what they ultimately do is is that they do not prepare science and technology well, and that can actually hurt you badly in the prelims examination. Because see, physics, sorry, polity, economics, history, geography, combinedly you will get around 60 questions. Okay, 50 to 60 questions will be from this topic, and out of which most students will be knowing around 30 to 40 questions. 30 plus questions you will be able to get from these subjects. But what is the minimum number of questions you have to get to clear the prelims? At least 60 questions you should make right, minimum. According to these days trend, minimum 60 questions should be made right, and the rest of the 30 questions you have to find from subjects like science and technology, environment, art and culture, ancient India, medieval India, which are all slightly on the difficult side, right? So you should give importance to these papers also if you want to comfortably clear the prelims. Mains, it is not that difficult. Even I was studying science and technology, is not that difficult. I'll show you the mains questions. So from a prelims perspective, do give importance to the science and technology paper, because first question I want to ask you is, do you know how many questions come in prelims from the topic of science and technology? Any idea how many questions come from the topic of science and technology into the prelims? Okay, so this is the number of questions which have been asked in the prelims in the last almost 10 years, because the current pattern of prelims started in 2011. Before that we had optional paper etc in the prelims. So from 2011 onwards we have this paper 1, paper 2, CSAT etc was introduced. So if you analyze the questions, There were a couple of years where they asked even 18 questions from science and technology. And on an average, every year they have asked, around 10. So now if you see the recent years analysis, every year it is about 10. So somewhere between 10 to 15 is the number of questions you will get from science and technology, out of which at least seven, 6 to 7, 7+ is doable questions. Okay, if you study science, if you spend time for science and technology, you will be able to crack 6, 7, even 8 questions out of 10 questions in science and technology. All solving all 10 would require you extra effort to be putting. All 15 questions are being asked. You can comfortably cross 10+ questions correct. Possible if you know the basics of science and technology. So do give importance. Now come to mains. How many questions come in mains from science and technology? Because you have already studied science and technology, you might be knowing all this information. Still, how many questions comes in mains? Mains, number of questions. Which part of the GS syllabus you have to study? Mains, science and technology. Which paper? That you will be knowing, right? GS3. Yes. So again, the current pattern of mains started from 2013. Before that, we had 2 GS papers, 2 optional papers, etc. Now 4 GS paper, 1 optional subject, etc. So the change started in 2013. So if you analyze the number of questions from 2013, in 2019, they asked 4 questions. That is, the number of marks was around 50. Or in all the other years, they asked generally 3 questions. So around 40 marks out of your 250 marks. That is 1/5 of GS3 paper is from science and technology. Okay, 1/5 of GS3 paper is from science and technology. Generally, you can expect 3 questions, either 2 10 markers and a 15 marker, or 1 10 marker, 2 15 markers. They will shuffle in between here there. So 3 questions is what you should expect from science and technology in the mains paper. Not just GS3 paper. There is a lot of other subjects also where they can ask science and technology, which I'll discuss. Now, before going to the topics, you already have been studying science and technology. If I ask you to write, if I ask you to tell me what all you have to study in science and technology, can you tell me what all topics have to be studied in science and technology? What all have been already covered? What all you have to study in science and technology? Space is already covered, right? Okay, space, nuclear science, astrophysics. Space science and astrophysics, they have been covered. Biotechnology, okay. These topics have been covered. Do you know the other topics which you have to study in the science and technology? Nanotechnology, biology, physics, okay. Done. Anything else? Blockchain technology, okay. I'm asking you what the syllabus asks you to study, okay? Not what all you have to study. Inside the syllabus, you have to study a lot of things. What all is there in the syllabus? This is what I'm asking. What all you have to study in the syllabus? Done? So from your answers, I'm just telling from your answers, you are not thorough with the syllabus yet. Okay. So there are many topics which UPSC specifically asks you to study in the syllabus, especially mains. Prelims, it just says general science. Okay. So general science, there is no elaboration. They don't even tell what to study. But from a prelims, some topics which are already told in the mains can come in prelims also. But there are some general things which you have to study in the prelims, which we will discuss. So I'm first discussing about the mains aspect. So there are some core topics which UPSC is asking you to study. And let me tell you, UPSC mains is clearly a syllabus oriented examination. They ask you questions from the syllabus. So first thing, you have to know the syllabus very well. First topic to be studied is everyday application of science and technology in life. What is happening in your life and how science and technology is getting applied. So everyday applications, their effects in science of science and technology. This is important for your prelims also. They ask this everyday science and technology, or the that is the mostly recent inventions, like all the generations of mobile, what is 5G, or this you will be wearing all this smart watches, your wearable devices, or OLED TV. So all these technologies, this all emerging technology, everyday application in daily life. First is what they ask, keep on asking about that. Second is achievements of Indians in science and technology, second topic. So what all Indians have achieved in science and technology, again this is an area from which UPSC have asked only two questions so far. So for sure, in future years, somewhere they will ask about contribution of Indian. So which Indian you will have to analyze and study. But definitely they are going to ask about some Indians, achievements of Indians. Third topic to be studied is indigenization of technology. What is indigenization of technology? What is indigenization? What is indigenization of technology? What do you mean by indigenization of technology? Yes, what do you mean by indigenization of technology? Indigenization means developing by ourselves. So make in India is indigenization. Atmanirbhar Bharat is indigenization. We have to develop things by our own rather than buying things from USA, Russia, Israel, etc. We have to develop things on our own. Yes, it is indigenization, creating things on our own. So we have, so ISRO is creating indigenized things in the space. DRDO is creating indigenization in the defense. So all this is first part. Okay, indigenization technology. Then comes awareness. Awareness in certain areas. So what is UPSC asking you to study? Where all you should have awareness? So UPSC is saying that you should have awareness in, again, awareness is also a very an abstract term. To what level you should have awareness? That means you don't have to dig deep. No PhD level knowledge is not required. Even master's level knowledge is not required. Bachelor level knowledge in all these things. First topic they are saying is information communication technology, ICT. Then they are telling about space. Then biotechnology, nanotechnology, robotics. So you should have an awareness about all this. This is what UPSC is asking you in the syllabus. So this is the syllabus. They are saying awareness in the field of IT and computers. We will club it together. Information communication technology, space, robotics, nanotechnology, biotechnology. These are the 5 areas UPSC has specifically given in the syllabus. Now, apart from these areas, there are a couple of more other areas which can be linked with our indigenization, science in everyday life, etc. All this can be linked. So, and they ask questions about that also. So, not specifically mentioned, but still to study, you have to study. One is nuclear science, nuclear technology, then defense, then green technology. Green technology. So this is not specifically mentioned in the syllabus, but they keep on asking about these areas. Nuclear technology I've already asked. Defense questions pop up in prelims. So far, I think they have not asked much questions in the mains of science and technology, but there are some topics, core topics, which will definitely be asked. Defense is a major science and technology area. Then green technology, all the new inventions which makes energy clean and green. This is there. Then the last topic in this science and technology is IPR, intellectual property rights. Okay, so copyright, patent, you are finding something new, you should have patent for it, because you are spending a lot of time, energy in finding something. You should have the exclusive right to manufacture it for few years. So that is what is given by this IPR, intellectual property right, patent, copyright, trademark, etc. So this is what UPSC is asking to study in the syllabus, out of which I think already space is covered, right? So, we link the basic science when we study this topic. Some basic elements of science will be dealt. So there will be no separate, will not be studying what we say, separate science as such. Physics, chemistry will not be studying, but we'll be focusing on the technology aspect. And whenever we are discussing certain technology aspect, if there is any science linked in that, we'll discuss that. Okay, this is how we'll be progressing. So space, I think, will be already dealt by sir, Sucharitan sir. I will be dealing with all these topics. I'll be dealing with information communication technology, defense, green technology, and one half of nuclear technology. This much I will be taking. Okay, this will be the portions I will be dealing with. So in defense, I'll be starting with defense. Okay, from there we'll progress to ICT and then to green technology and yes, robotics also. Robotics I'll link with ICT. So these are the topics I'll be dealing: ICT, robotics, defense, and green technology. So space, I think Sucharitan sir is dealing. I think he might have started biotechnology also. While dealing with space, astrophysics will be taught. This is how, and IPR, wherever there are some IPR issues, we'll discuss that. And again, when we discuss each topic, if at all there is any indigenization, this something India's manufactured, we'll discuss that. If at all there is any contribution of any specific person, we'll discuss that. So this is how we'll get along with the first topics: indigenization, contribution of Indians, etc. And everyday application will keep on coming. We will not study it separately like these are the everyday applications of science. No, see, especially when we study ICT, we'll study about a lot of technology which we are using in everyday life. Okay, so this is all, this will all come in our while we discuss these topics in between. Now syllabus, this I told you. Now another thing to do is understanding the way UPSC is. Yes, NCRTs I'll come to. Please wait. I'll come to the books. Another thing to do is understanding the way UPSC is asking questions. You are reading a lot of things. Even now, you will be reading a lot of books, lot of things you are reading. But do you know how UPSC is asking questions? This is the most important thing you have to keep in mind. So understand the thought process of the person setting the questions, rather than reading everything and going to the exam hall not able to write anything. Understand the thought process of the person setting the questions. That is very, very important. If you understand that, see, again, the most important thing in clearing your prelims is doing the UPSC question papers again and again, because then only you will know how UPSC is setting these questions. I'm not saying that no, test series is not important. Obviously you need to have that practice, but understand how UPSC is making a statement wrong, how UPSC is framing a question. That should be understood. So similarly in mains, have you gone through the previous questions of mains in all the subjects, any subject, science and technology? Have you done that? Yes, science and technology. Have you gone through the previous mains questions? I'm not asking prelims, mains. No. So again, if science and tech, not just science and technology, all the subjects. What all have been taught in science and technology so far? What all have been taught? Space, astrophysics, biotechnology is over. Biotechnology has started. Space is over. Okay. So you have already studied one major chunk of this science and technology. Space is a very, very important topic. Now, what all questions have been asked from space? This you should understand. So see, everyday application. I told you this mains is a syllabus oriented examination. I'll give you examples. I'll tell you how exactly it is a mains oriented examination. Everyday application of science. See, this is a question which UPSC asked in 2020. How is science interwoven deeply with our lives? What are the striking changes in agriculture triggered by science-based technologies? Even a 10th standard student, even a 12th standard student can attempt this question, right? Now the challenge is how you write a good answer for this, because everybody will attempt this question. A person writing mains definitely will have a basic knowledge to attempt this question. Why the examiner? This is a 10-marker question. Why the examiner will give you 4 marks and the other person 3 marks? Or why the examiner will give you 5 marks? You should have enough content in the paper which is different from others, different and unique. So give examples, give as many examples, give as many areas as possible where science is getting used. So this is how you'll get more marks. Then second aspect, again the question has 2 parts, so you'll have to write both aspects. Second is how agriculture is influenced by science and technology. So this was a question in 2020. Now, before this, questions like this. So application of science in everyday life is more important for prelims. Before this, they asked in 2014, etc. 13, 14, new pattern started. There the questions were very specific. Okay, they asked engineering level questions at that time. But nowadays, if you analyze the trend of science and technology, they are not asking specific questions. Engineering type questions are not getting asked. Very generic questions are getting asked. Again, I'll show you. So in 2014 they asked about drug resistant diseases. Even this can be linked with slightly with what we say biotechnology also. There is something called a drug resistant diseases. So we have a problem called antibiotic resistance. So the diseases where we can take antibiotics and cure, even if you take antibiotics, the disease will not cure. So this is antibiotic resistance, drug resistant diseases, the reason for that. And then they asked about fixed dose drug combinations. Even that can be a part of biotechnology also. But yeah, you take certain medicines where where you mix certain chemicals rather than having one chemical. You mix chemicals and have it. That is fixed dose drug combinations. About that they asked UPSC. Then see, umpire decision review system. Those who are watching cricket will be knowing this UDR, umpire decision review. But what did UPSC ask? UPSC asked what are the components of that? How silicon tape can cheat that, because the system was just getting introduced at that time. People would have read about it, but this was a unique specific question. Then they asked about FRP, fiber reinforced plastic composite material. Again, engineering students might have studied it because this is a very static area. FRP, composite materials, etc. It is difficult from a science perspective. We mostly cover the current aspects. Okay, we link science with current aspect because we in a stipulated time of say 10 months. See, science you can study for 3 years. BSc, MSc, and all you can study for years. But even then, we cannot cover all this area, entire science. So we focus on those areas which are highly current oriented. Maybe UPSC also understood that it is not possible for the students to dig into science and study all these aspects. So they stopped asking all these things. But for prelims, they keep on asking some areas here and there. So FRP composite materials, fiber reinforced plastic. Then they asked about 3D printing. Obviously, this is a new technology. We'll have to study about 3D printing. So they asked about 3D printing. Then they asked about yeah, these are the technologies in everyday life they asked. Then, as I told, second topic, contributions of Indians. Even though the new syllabus started in 2013, for the first time they asked about the contributions of Indians in 2018. For 13, 14, 15, 16, 17, 5 years, no questions. 18, 19, back to back they ask questions. 20, no questions. So for sure, 21, 22, 23, 24, we don't know when they will be going to repeat this, but you have to be prepared about the contributions of Indians. Okay, prepare 150. See, what is the number of words you have to write in these answers? 150 words or 250 words? So mostly contributions they ask for 150 words. Okay, so be prepared with 150 words. 150 words meaning at least 5-10 points you prepare about the contribution of these people. And when the exam comes, don't be surprised. Oh, I never thought that I'll have to study. Be prepared because UPSC is asking you to prepare the contributions of Indians. So in 2018, they asked about Satyendranath Bose, because from the time this Bose-Higson particle etc. are getting discovered from 2013, we are expecting this question. Finally, they asked about this in 2018, and in 2019 they asked about Vishwesharaya and M.S. Swaminathan. So Vishwesharaya is the father of Indian engineering. His birthday we celebrate as Engineers Day. Contributions of Vishwesharaya in the water engineering, and M.S. Swaminathan, the father of our green revolution. His contribution in agriculture. So there are a lot of people who's left out there who can be asked, starting from APJ Abdul Kalam to Vikram Sarabhai. So all the physics, all the Nobel laureates in science, all these people can be asked. So wherever you are finding, you don't have to study hundreds and thousands of scientists. No, India do not have hundreds and thousands of scientists. Maybe 10 scientists you have to study, 10 people or 15 people. Their contributions might have to be studied, but that's all. So be prepared on all these aspects. They will again ask. Then indigenization. Again, very, very favorite area of UPSC. In almost all areas, I think, all areas of the syllabus, they have asked some questions about indigenization. So I've linked it accordingly. So indigenization in space, I have put it in space. Indigenization in biotechnology, I have put it in biotechnology. But two specific areas. So in 2017, they asked about nuclear technology, nuclear science. So this is not part of syllabus anywhere. So give an account of the growth and development of nuclear science and technology in India. And we have a 3-stage nuclear program. So out of which there is a reactor called fast breeder reactor. So they asked what is the advantage of this fast breeder reactor. So very basic question, India's nuclear policy, and then what is the use of fast breeder reactor. And in 2014, they asked a generic question that the fundamental research in science is declining or not happening, whereas more people are attracted towards engineering, business, MBA, etc. Why it is a reason for this? And the question was critically a comment. So that does not mean the statement need to be fully correct. You can counter it also. You can say that no more lot of people are coming to research in science. That aspect can also be written. So it is a critically comment question, and they are saying that scientific research in Indian universities is declining because a career in science is not attractive as business operations, engineering, or administration, and universities are becoming consumer oriented. Critically comment. This was a generic question on how research is happening in India. Now, space. Again, an area from which UPSC asks a lot of questions in the mains as well as prelims. So in last question was in 2019. So 2020, no questions from space. So 2021, definitely you should expect a question from space. Okay. So 2019, they asked about our space station. So ISRO, you might have studied about space station. ISRO has announced 7 ambitious missions. Okay, out of which, including this Gaganyaan space station, etc., out of which they asked space station in 2019. 18, sorry, not 18, 17, they asked a question before that. And this was regarding manned mission. So I think ISRO announced manned mission in 2018, I guess, or 19. But UPSC asked one step ahead. They did not ask about space mission, manned mission. They asked why we are not having manned mission. Okay, now we have Gaganyaan. We are going to send astronauts into the space probably by this year end. But 2017 they asked why we are not sending manned missions. Then C16, a question regarding India's achievements in space science technology. What has India done in space science? So ISRO's contributions, if you know, you can answer that question very well. And then 15, a specific question on standard positioning and protection positioning. So these were the questions from space. Now come to robotics. Only one question have been asked from robotics so far. That is how we can use robots in the area of prohibitive labor. So there are areas where human working is difficult, like deep mines or manual scavenging, etc. So here we can replace human labor with robots. So a question was asked in 2015. For sure, UPSC will repeat a question on robotics in the upcoming year. What question they are going to ask, from which area of robotics, we don't know. But a question, because robotics is there in the syllabus, for sure a question will come on robotics. Now come to nanotechnology. So only from 2013, if you analyze, 2 questions have been asked. 16, they asked a question which was about why it is one of key technology, why nanotechnology is one of the key technologies, and describe the features of India's mission on nanoscience. So India's mission, wherever we have some mission on something important. So our mission on nanoscience was asked in 2016. So 17, 18, 19, no questions. So after 17, 18, 19, everybody was expecting a question on nanoscience. Did not ask. 20, they repeated. They asked one specific area, how nanoscience is helping the health sector. Okay, so again, nanoscience technology questions. Then biotechnology. 3 years back to back they asked. 17, 18, 19. Back questions on biotechnology. 19, they asked how biotechnology is helping farmers, agriculture. 18, they asked about why there is so much activity of biotechnology in our country. See, this you see the pattern. 1 year they ask about what is happening in why there is so much activity in nanotechnology. Next year they ask why there is so much activity in biotechnology. 1 year they'll ask what is happening in nanotechnology in India. Next year they will ask what is happening in biotechnology in India. Third year they'll ask what is happening in defense in India. Fourth year they'll ask what is happening in nuclear science. Fifth year they'll ask what is happening in space. This will get repeated. This is the pattern in which, and inside that also they can ask specific questions, like they can ask Gaganyaan, they asked about space station, specific application, they asked about the biopharma mission. Specific questions can come, but be prepared on a generic perspective. Whatever there is there in the syllabus, be prepared. So 18, they asked why there is so much activity in the field of biotechnology and this achievements in the field of biopharma, or what is the benefit in biopharma. And 17, a specific question on stem cell therapy. So advantages, disadvantages of stem cell therapy. This was the questions from biotechnology. Now come to IPR. So 2019 and 15, 2 questions were asked. Actually, 2019 questions answer was already there in 2015's question. So if you had read at least the question papers, previous question papers, you would have been able to write some aspect of 19 question. What did they ask in 19? See, how is the government of India protecting the traditional knowledge of medicines from patenting by pharmaceutical company? We have a lot of traditional medicines. India is rich in traditional medicine. So this pharmaceutical companies can understand the properties of these medicines. They can make capsules out of this medicine, and then they can patent it. Once they patent it, only they can manufacture it. But this is our traditional knowledge. How it is right for other companies to patent it? It is not right. So they asked how we are doing it. In 2015, read the question. What did they ask? India's traditional knowledge digital library. We have a traditional knowledge digital library which has a database containing formatted information of more than 2 million medical formulations. Is proving a powerful weapon in countries' fight against erroneous patents. So we have a traditional knowledge digital library where we have already stored 2 million database of 2 million medicines are already there, which is helping us in the fight. So see, question, answer. UPSC itself are given. So this is again, maybe one examiner has said both these questions. His area of expertise might be patent and traditional medicines. Again, after a couple of years, they might ask some questions about traditional medicines and patenting. So this is why I said understand the examiner's mind. So what is the pros and cons of this database being available publicly? That was a question, but still, yeah. Then they asked one question in 2015 regarding generic, what we say, definitions of this patent. What is patent? What is trade secret? What is copyright? That was asked. And in 13, a question was asked from the patent law. We have a patent law. So one section, section 3D of this patent law and how it is getting misused, all these things were asked. So patent law has to be studied, then you will understand, you will be able to answer this question. So what I'm telling it is not about whether you know answers to this question or not. But my point is, you should understand that mains examination especially is a syllabus oriented examination. Prepare the syllabus. So even if you do not read any book, take the syllabus, prepare 150 250 words for every word in the syllabus, you will clear mains. This is how you should prepare the mains, okay, from my understanding. Now I told you this is what you have to study in your paper 3 in science and technology. But questions come in science and technology not just from paper 3, but even in other papers questions come, like what all you have to study in your GS paper 1. I hope you know that much knowledge. If not the whole syllabus, what all topics have to be studied in GS paper 1? Subjects in GS paper 1: history, geography. Done? Okay, society. So in GS paper 1, you will know you have to study art and culture, history, Indian society, geography, etc. So in geography, they asked 2 questions. Okay, they have asked about this Juno mission in geography, GS paper 1, and they have asked about IRNSS, India's regional navigation system, or NAVIC as it is known as. See, these 2 topics you would have studied in your science and technology, but they ask these questions in geography. Okay, so it is not, UPSC is known for this. They at times they ask questions in of paper 1 and paper 2, like slight linkages here and there, like South China Sea. There was a lot of debate going on about South China Sea. There was a lot of issues going on. People were expecting a question about South China Sea in paper 2, international relations, but they put it in paper 1 and asked about the geographical aspect of South China Sea. That way also they can ask. So in paper 1 they have asked about science and technology topics. In paper 2, already we saw a question. They asked about the application of, I think, biotechnology in health. Already one question was asked. No, nanotechnology in health. One question was asked, linking with health. So health and education is a part of your paper 2. Health, education, and application of technology in health and education can be asked. One area. Second area is the e-governance or the digital governance. So there is something going on called fourth industrial revolution. Have you heard about it? Have you heard about this fourth industrial revolution? Yes. So a lot of things are causing this fourth industrial revolution, which we will discuss in the ICT topics. Lot of new things, artificial intelligence, yes, one digitization, artificial intelligence, Internet of Things, blockchain technology, machine learning. So a lot of things is together contributing towards this fourth industrial revolution. We have been expecting a question about fourth industrial revolution in science and technology for quite long. They have not asked it because this topic of fourth industrial revolution started the discussions in 2015. In 2015, in the World Economic Forum in Davos, they started discussing about a fourth industrial revolution, which is happening, which is making society more disruptive. Changes are happening very fast. So from there onwards, we are expecting a question on fourth industrial revolution and the different areas which is causing this fourth industrial revolution, be it artificial intelligence, be it Internet of Things. We are expecting questions on this, but they have not asked any questions about this. But this year in 2020, they asked about how industrial revolution is affecting the digital governance. They brought industrial revolution in GS paper 2 and asked about it. So you should know some technical aspects. The paper 2, you do not have to give so much of science and technology, but still, what is this IoT, fourth industrial revolution, and how it is helping digital governance? This was asked. Then in paper 3, GS paper 3, so obviously science and technology is a part of GS paper 3. You can expect 3 questions. At least 40 marks will be sure shot. 40 to 50 marks will be sure shot from science and technology. In addition to that, there are areas. So in syllabus itself, it is said technology aid to farmers. Technology and agriculture is one area you have to focus. See, 2020, they asked a generic question on how science is helping farmers. Then they asked about farmers being helped from biotechnology, nanotechnology. All these things can be asked. So agriculture and farmers is one area from which they can ask question. Then internal security. So internal security, have you studied about CIBMS? Have you studied about CIBMS? CIBMS, yes, no? No. So CIBMS is Comprehensive Integrated Border Management System. Comprehensive Integrated Border Management System, where we are using technology to guard those areas of the border where we cannot manually guard the border. So there are a lot of areas in India, Pakistan, India, Bangladesh, India, China borders where it is not possible to our soldiers to be physically there and guard the borders. There we can use technologies to guard the borders. So there are a lot of new technologies which are getting developed, which can be applied in our border management. So there also technology-based questions can come. So it is not just science and technology in GS paper 3. There are other areas from which they can ask science-based questions. Then even in GS paper 4, there can be ethical dilemmas because of science and technology, and all. No, there is a new web series coming in Hotstar because it is based on technology. I think it is going to be an interesting series. So again, automatic car had hit the person. The trailer shows all these things. So who is the culprit? So there are a lot of ethical dilemmas which can happen due to science and technology, artificial intelligence. Driverless cars, automatic self-driving cars. So there are a lot of ethical dilemmas. These can be case studies where you can apply your science-based knowledge. So again, GS paper 4, even though not to that extent, but even then, ethical dilemmas can come from the applications of science and technology. And then the essay paper. So I hope you know the pattern of essay paper. You have to write 2 essays. 2 essays each out of 125 marks. So total 250 marks. And for each question 1 and question 2, you will be given 4 options, right? You will be given 4 options. And one option out of these 8 options, one option will be mostly a science-based topic. So 8 questions will be given, out of which you have to write 2 essays. One topic will be mostly a science-based topic. And it is easy to write science-based essays because you will have a lot of content. Now you have to just consolidate it and make it an essay. Don't make it a science journal, but you have to make it an essay. But still, you will have a lot of content, while writing this science-based essays. So this is again an application. So 125 marks flat will come in essay, and this can be from science. Already they have asked about artificial intelligence, I think last year. So even though they have not asked about artificial intelligence in GS paper 3, they have asked about the same in essay, artificial intelligence. So similarly, you can expect more questions from science even in essay. So this is what I told. Even though we in direct science-based questions can be say up to 40-50 marks, up to 150-200 marks questions can come from science and technology. If you analyze including this essay, questions can come around 175 to 200 marks. Questions can come in all GS papers together. So this is the relevance of the paper of science and technology. Now, this is something which again would have already been discussed. So, Citizen sir would have definitely told you what all sources to study. First source I will tell you is first source should be your class notes, because class notes will be the simplest way in which things will be explained. Okay, if you read a book, lot of information which is needed, not needed, everything will be filled. In class, we will consolidate it and we'll summarize it into the shortest possible way, and the most important topics or important information only will be discussed. That topic can be, again, see, each topic can be discussed from even a PhD level. We will not go deep into all these topics. What is required for you to clear the exam or answer this question, that much only we will be focusing. So first thing is class notes, and second one, standard text. The one standard text. This text can be the NCERT of class 9 and 10. There is an old NCERT of class 9 and 10 called Science and Technology. That can also be read. Or, our academy has a Science and Technology textbook. Even this is fine, to get the basic knowledge of all the topics. This is also good. Or any science book. You do not have to read this thick, fat 400, 500 pages books. Not relevant, not worth. Even if you read that entire 400 pages, you may not be able to answer 2-3 questions. So not worth. So first is class notes. Second is one standard book, which can be your academy book, or you can read this NCERT of class 9 and 10. Old NCERT of class 9 and 10. I think the book name is Science and Technology. Then obviously newspaper. So whatever updates are coming in newspaper, at least Hindu you should read. If possible, Indian Express. Again, Indian Express is not the new Indian Express which we get here in South India. There is the Indian Express. Just, in North they publish the Indian Express. That is a good paper. In soft copies we will get. If again not compulsory, initial years, at least in the first year, you will not be able to read 2 papers for sure. Hindu is sufficient. At least go through Hindu meticulously. Then there is a magazine called Science Reporter. Again, not mandatory. This can be read to boost your scientific temper. I think this magazine can be downloaded free of cost now. Old versions are available free without any paying anything, and you can read these books. Okay, if you want to boost scientific temper, not relevant. Important things of Science Reporter will be discussed in the class, and even in the current affairs magazines they'll summarize it. Then this source called India Science Wire. This is a website. It is like a PIB of science and technology. All the new information of science and technology. So this is a link, vijnanprasad.gov.in. If you go there, you can get the current updates, the things which the government is doing in science and technology. In addition to that, I'll say PIB is also important. So here, just not this, you can look into the PIB also, and whatever science-based topics come in PIB can be updated. But the problem is that time. We do not have time to go through PIB every day, which is a bulk of things. Then the science and technology chapters of India yearbook. And the department website, especially DST website. See, the thing is that the best source of information to prepare for UPSC is government sources, be it government publications, government magazines, government websites, because UPSC will ultimately take questions from these government websites, not our monthly magazine or not any academy's book. Ultimately, questions will be picked up from this government sources. But again, going through all the government sources, picking up all the information published by all government sources take a lot of time. That is why we are not going through the government sources. Rather, all this information will be summarized in the monthly magazines, and we go through these monthly magazines. That is why how we read all this information. But if at all you get the chance to go through at least DST website, every ministry publishes an annual report of what all they have done in the last year or what all is their priority in the next year. At least that much you can read. Again, if the report is say 100, 200 pages, I'm not asking you to read the whole report. At least read the introduction chapter. So there will be a project summary of whatever they are going to tell in the chapter. Read that chapter and maybe the first and last paragraph of every chapter. Introduction and conclusion. Maybe the headings you can glance. So in like 30 minutes, 1 hour, you will finish the report and write the important things which you want, which you might use in your mains or prelims. That much is needed. Not like sit, read the report head to tail, spend 1 month reading the report, no relevance. That is not what I'm asking. Okay, summary of this report or whatever is there in the report, you can glance through, and whatever you feel important, you write it as in your notes. Make it part of your note. That is one thing. Then this India yearbook, again a good source to prepare science and technology, especially for prelims. Apart from this, I'll suggest Niti Aayog reports. So whatever reports Niti Aayog is coming out with is relevant. Again, even if you're not able to study the whole report, is the board blurred? Yes. E is the blur. Zoom in the Rashna. In the settings, okay. Okay. So this Niti Aayog reports. Do go through this Niti Aayog reports again. You can read it. You can glance it in a way as I told you, bro. Change ചെയ്യുന്നുണ്ട്. Okay. Okay. So this is about the sources. Now the first topic we will be discussing is defense. Any question you want to ask from what we discussed so far? Any doubts? Any questions? So generally, your sessions are from 2 to 4:30 and 5 to 7:30, right? Two sessions. Am I right? 2 to 4:30 and between this 2 to 4:30, yeah, I'll tell about that. Between this 2 to 4:30 session, do you get a break? Okay, 5 minute break I'll give. Fine. And regarding one question is regarding the new NCRTs. The new NCRTs, 6 to 12 NCRTs. Selective reading. What is a selective reading? See, all these NCRTs can be downloaded. No need to buy any of these NCRTs. If at all we are discussing something in the class and the same things are discussed in your NCRT, you can read that chapter. That much is needed. There is no need to read NCRT head to tail, especially science and science NCRTs, because these days they are asking very minimal questions from basic science. In prelims, means they ask nothing. In prelims, very minimal questions, some biology questions, if at all they ask, they will ask. That is all. Apart from that, nothing we ask from science these days. So it is not worth reading the entire science NCRT. So you can glance through 6 to 10 NCRT, especially 9, 10, 10, 11, 12 NCRT. If at all we are discussing, see, I am discussing something about ICT. Same things are there in your, same thing discussion is about in your NCRT. Read that chapters. Okay, that is, we discuss something about communication. The same chapter is there in your physics NCRT. Read that chapter. That is all what is needed regarding the new NCRTs. So first is defense technology. So in defense technology, uh, organization setup and CDS I'll discuss in the end. So defense technology can be divided into two parts. There is a technical part and there is a non-technical part. Defense technology, we'll have to discuss about the technical part. Non-technical part. In technical part, there are three systems which have to be studied. There is a striking system, there is a patrolling system, and there is a surveillance system. There is striking system, there is patrolling system, and then we have to study about the surveillance system. So what is the striking system? Striking system is about missiles. Okay, so in striking system, we'll discuss ballistic missile, cruise missile, anti-ballistic missile, anti-cruise missile, and then some other special missiles. Like now we have a anti-satellite missile, anti-radiation missile. So there are some special missiles which we'll discuss. So this is what we'll study in the striking system. Striking system. We'll discuss about ballistic missiles, cruise missiles, anti-ballistic missiles, anti-cruise missiles, special missiles, etc. So what all is part of our patrolling system? So our patrolling system will have aircrafts, helicopters, floating ships, military tanks, floating ships, military tanks, submarines. So all these things should be the part of our patrolling system. Then in surveillance, we'll study about radar, lidar, sonar, then unmanned aerial vehicle, UAV, unmanned aerial vehicle. So all this is part of our defense syllabus. So if you are done with this, defense syllabus is over. So this is what you have to study in our defense syllabus. And in non-technical part, there are two topics which have to be studied. In non-technical part, we have defense operations and defense exercises. Okay, exercises we do with other countries and our Army, Navy, Air Force exercises. So this is part of our this the non-technical part. This is a very static and fact-driven topic. The defense operations and defense exercises, which can be read from the India Yearbook. India Yearbook defense chapter covers it very well. All the names of those operations exercises is covered in the India Yearbook defense chapter. So this topic we will not be discussing in the class, the non-technical part. Okay, this can be read from the India Yearbook, but technical part we will cover very elaborately. All the aspects we will cover very elaborately. The technical part. So this is the defense technology. First, we will divide it into two: technical part and non-technical part. Are you able to read all this? Okay. And are you done with this? Can I move to the next topic? So when I ask whether you are done or not, if anybody wants me to wait, you can just type wait. That much only is needed. Okay. If anybody wants me to wait, you can just type wait. If there are no waits in the chat, I'll move to the next topic. Now, before going into this technical part, there are some terminologies which you should know. Okay, next you can write terminologies. Some terminologies have to be understood. Terminologies. First is armed forces. Armed forces. What is armed forces? Armed forces. Is it army? Armed forces. Is it army? Or is it navy? Or only army? Only navy? Or air force? What is armed forces? So armed forces is army, navy, air force and paramilitary forces. Army, Navy, Air Force, and paramilitary forces. So some paramilitary forces are also included in armed force. We have Border Security Force (BSF), Indo-Tibetan Border Police (ITBP), Sahastra Seema Bell (SSB). All these things you will study in your internal security. So all these paramilitary forces can also be included in armed forces. Armed forces. Army, Navy, Air Force, paramilitary forces. So paramilitary forces actually assist the military. That is why they are called paramilitary forces. Military will be there in assistance to them. Paramilitary will also be there. So this is armed forces. Then there are sub troops. Sub troops. So each armed force is actually subdivided into three. We have infantry, we have cavalry, and we have artillery. There are three sub troops: infantry, cavalry, and artillery. Infantry, cavalry, and artillery. What is infantry? Infantry operates from ground. Infantry operates from ground. Cavalry operates from animals. Cavalry operates from animals like horses, camels, etc. They can operate. And artillery operates from vehicles. Artillery operates from vehicles. So this is sub troops. There can be infantry, cavalry, and artillery. Infantry operates from ground, cavalry operates from animals, and artillery operates from vehicles. Then there is something called warhead. So when we discuss missiles, etc., we'll keep on discussing. The warhead is this many kilogram. So there we will not discuss again what is a warhead. So that is why we are discussing certain terminologies. What is a warhead? See, warhead is the explosive head of a missile. You are launching a missile. Now it will strike somewhere and it will explode, right? Why it is exploding? Because it contains something at its head. So there is an explosive head of a missile. So this is called, even any weapon we use. So it will have an explosive head. This is, which will be called warhead. So explosive head of a missile or a weapon is called a warhead. Explosive head of a missile, weapon, etc. is called a warhead. Warheads can be classified into three. There can be conventional warheads. There can be conventional warheads. There can be strategic warheads. Conventional warheads, strategic warheads, and nuclear warheads. Sorry, biological warheads. Biological warheads. So these are the three types of warheads. The conventional warheads is when we use weapons made of normal chemical explosives. So this here we use weapons made of normal chemical explosives. Normal chemical explosives like say RDX, TNT, aluminum powder, all these are normal chemical explosives. Okay, so this is conventional weapons. Strategic weapons, we use nuclear weapons. Strategic is about nuclear weapons. And in biological weapons, we use biological weapons like viruses. See, anthrax, etc. can be used as a biological weapon or biological warhead. You use a biological weapon in a biological warhead. So these warheads can be classified into conventional warheads where we have conventional chemicals like RDX, TNT, etc. Then strategic warhead is using nuclear weapons. Biological warhead is using biological weapons like viruses, anthrax, etc. as an example. Now India has both conventional and strategic. We do not have a biological warhead. We have conventional and strategic warheads. We do not use biological warheads. India has conventional and strategic warheads. We do not use biological warheads. Next, what you understand by the term theater? In defense, what is a theater? Movie theater? Operation theater? What is the theater? Or what does theater mean in defense? What is the meaning of theater in defense? Any idea? Theater means battlefield. Theater means battlefield. Theater means battlefield. Then wherever we are mentioning striker, wherever you see the term striker, understand that this is a missile. Striker means a missile. Wherever we are mentioning about something called tactical, that means it is highly precise and highly accurate. Tactical means highly precise and highly accurate. This is tactical. Highly precise and highly accurate. Then the term surface. Surface. So generally when we say surface, it means land. right? We say surface in land. But in terms of defense, surface can mean a land, a floating ship, or even a submarine. So this all refers to land. So land can be a, surface can be land, floating ship, or even a submarine. Or even a submarine. So the missiles which we launch from submarine, what is it called? The missile which we launch from submarine and which travels underwater. What is that missile called? The name of the missile which we launch from submarine is called? Any idea? Torpedo, correct. Torpedo. So torpedo, even when we launch a torpedo, we are launching it from underwater, but we'll call it a surface. It is launched from surface. It is attacking another torpedo. We'll say it is a surface to surface missile. We do not have a category called underwater missile. So it is a surface to surface missile. So here, what we say, land, floating ship, and even submarines are considered as surface. All of this is considered as surface. So next is we discussed all these systems, right? So we will go one by one. We discussed all these systems, right? So first we'll discuss about the striking system. So first heading you can write striking system. Striking system. So I'll give you a small 5-minute break. Then we'll come back and discuss about the striking system. So first we'll discuss the striking system. Striking system is about the missiles. So what is a missile? That is what we'll discuss first. So missile is a kind of, just write what is a missile, then we'll discuss it. Missile is a kind of guided weaponry system. Guided weaponry system. Missile is a kind of guided weaponry system. It has its own inbuilt propellants. It has its own inbuilt propellants and aerodynamic control. It has its own inbuilt propellants and aerodynamic control for striking the target. For striking the target. For striking the target in a much precise and accurate way. In a much precise and accurate way. In a much precise and accurate way. So what is this? So missile is a kind of guided weaponry system. So what is this guidance, or what provides this guidance for a missile? So this guidance is provided by, say, radar, lidar, sonar, all these things. So guidance is provided by all this equipments, radar. Even navigation instruments can provide this guidance. Okay, navigation instruments like GPS. Your navigation instrument like GPS can provide this guidance. So it is a guided weaponry system. What is weaponry system? Weaponry system is nothing but warheads. So all missiles will have weaponry system is warheads. So this warhead can be conventional, strategic, biological, all this is possible. Conventional, strategic. So this is the warhead. So missile is a kind of guided weaponry system. It has its own inbuilt propellant. So you would have already studied about propellants in the space. So here what is a propellant? What is a propellant? Yes, propellant is a combination of fuel and oxidizer. Okay, so propellant is a combination of fuel and oxidizer, and once the propellant is burned, you know how rockets are used in space. So once this propellant is burned, they can provide thrust for action. The propellant is burned, and this will move up, and this gas will move down. So this is how the thrust is provided for this motion of the missiles. So propellant is a combination of fuel and oxidizer. Propellant is a combination of fuel and oxidizer. Propellant is a combination of fuel and oxidizer. Once propellant is burned, it can provide thrust for motion. It can provide thrust for motion. It can provide thrust for motion. So here we use in missiles we use solid and liquid propellants. Okay, only two types of propellants are used. One is solid, other one is liquid, and then we can use a combination of both. So solid, liquid, and then we can have a combination of solid plus liquid. That is all. So these are the propellants we use. So it has its own inbuilt propellant system. Then what did we say? And aerodynamic control for striking the target. What is this aerodynamic control? So aerodynamic control is basically a feature of this aeroplanes wherever we have wings. So when we have wings, there is motion which is happening in the three directions: X, Y, Z. In all these three directions, you can move. So this is the aerodynamic control. So for aerodynamic control, wings are mandatory. So that is why if you observe missiles very closely, all missiles have wings. So what is the purpose of these wings? Wings are required for this aerodynamic control. There are three types of aerodynamic control. There are three types of aerodynamic control. First one is called roll. Roll. Roll is a rotation around front to back axis. Front to back axis. Roll is the rotation around front to back axis. Second is called pitch. Second is called pitch. Pitch is the rotation around side to side axis. Pitch is the rotation around side to side axis. The rotation around side to side axis is called pitch. Side to side axis is called pitch. And third is called yaw. Yaw. Yaw is the rotation around the vertical axis. Yaw is the rotation around vertical axis. Yaw is rotation around vertical axis. So terminologies we discussed. So striking system, this is a photo of a BrahMos. We'll discuss BrahMos. So missiles are guided weaponry system. It has its own inbuilt propellants and aerodynamic control. I'll just show you a video of this aerodynamic control. All those three motions: pitch, roll, yaw. So pitch is the motion around roll, front to back, and yaw is the vertical axis. Pitch, side to side, roll is the front to back, and yaw is the vertical axis. So this is a motion, three motions. Pitch is side axis, roll is front to back axis, and yaw is the vertical axis. Clear? So this is the motion. This is just for your understanding. I showed this aerodynamic control. Now, if I'll tell you a couple of lines. Yes. Let me know if it is right or wrong. Missiles can operate in outer space. Is it true or false? Missiles can operate in outer space. True or false? Missiles can operate in outer space. It can operate. Okay. So for all ballistic missiles, we'll discuss ballistic missile. For ballistic missiles, you will see all missiles starts from surface. So initial motion is through atmosphere, then it will travel through outer space. Outer space travel is mandatory for a ballistic missiles. So it can travel through outer space. Missiles travel underwater. True or false? Missiles travel underwater. Yes, we already discussed about one underwater missile, torpedo. So missiles can operate Can write missiles can operate in atmosphere. Yes, missiles can operate in atmosphere, outer space. Missiles can operate in atmosphere, outer space, and even underwater. Missiles can operate in atmosphere, outer space, and even underwater. Missiles can operate in atmosphere, outer space, and even underwater. Now I'll tell you another statement. Missiles can be used for constructive and destructive purposes. Is it right or wrong? Missiles can be used for constructive and destructive purposes. True or false? Actually, it is false. Missiles can be used only for destructive purposes. Okay, there is no constructive purpose of a missile. Missile can be only used for destructive purposes. So missiles are used for destructive purposes only. Missiles are used for destructive purposes only. And each missile will have their own range. Each missile will have their own range, like short range missile, medium range missile, long range missile, etc. So each missile will have their own range. Each missile will have their own range, which is decided at the time of manufacturing itself. Which is decided at the time of manufacturing itself. So when we are manufacturing something itself, the range will be decided. Why we are discussing all this is, now we will compare it with a rocket. For rocket, there are slight changes. So that is why we are discussing. So this is, missile can operate in atmosphere, outer space, underwater. Missiles are used for destructive purposes only. Each missile will have its own range, which is decided at the time of manufacturing itself. Now, what is the pathway of a missile? Pathway of a missile. So there are three phases in the pathway of the missile: phase 1, phase 2, and phase 3. There are three phases in the pathway of a missile. So phase 1 is called the ascending phase or lifting phase. So initial phase is called the ascending phase or the lifting phase. The ascending phase or the lifting phase. Second, it travels. Traveling phase or the transition phase. Second phase is called the traveling phase or the transition phase. And phase 3 will be called the descending phase or the returning phase. Returning phase, descending phase, or it is also called the striking phase. The striking phase. So this is where the missile actually strikes the target. So there are three phases in the pathway of a missile. First phase is called the ascending phase or the lifting phase. So where the missile rises. Second phase is called the traveling phase or the transition phase. And the third phase is called the returning phase or the striking phase. So these are the three phases in the pathway of a missile. Now we'll discuss about all this when we discuss ballistic missiles, cruise missiles, etc. So you know the pathway. So there is a ascending phase, then there is a traveling phase, and then there is a return phase or the striking phase. Third phase is the return or striking phase. Next, we'll discuss rocket. You might have studied about rockets in space also. So rockets are unguided weaponry system. Unguided weaponry system. Unguided weaponry system capable to strike the target. Capable to strike the target in less precise and less accurate manner. In less precise and less accurate manner. in less precise and less accurate manner. So here, it is not guided, so it will be less precise and less accurate. Now, I'll give you a couple of statements. Tell me if it is true or false. Rockets can operate in outer space. True or false? Rockets can operate in outer space. True or false? Rockets can operate underwater. True or false? Rockets can operate underwater. True or false? Okay, so rockets can operate in atmosphere and outer space, but it cannot operate underwater. Missiles can operate even underwater, but rockets can operate in outer space and atmosphere, but not underwater. Rockets can operate in atmosphere and outer space, not underwater. Not underwater. Not underwater. Now, tell me if this is right. Rockets can be used for constructive and destructive purposes, right or wrong? Rockets can be used for constructive and destructive purposes, right or wrong? Correct. You would have already studied which is the constructive purpose of rockets. Where do we use rockets in a constructive manner? Where do we use rockets in a constructive manner? Yes, in space, rockets are used as launch vehicles. Rockets are used in launch vehicles. So rockets can be used in constructive and destructive purpose. So destructive purpose is defense. In defense, we use it for destruction, but in space, we can use it for as a constructive purpose. Space, we can use rocket as a constructive purpose. So rockets can be used for destructive and constructive purposes. And the rocket range is determined. Rocket range is determined only at the time of launching. Rocket range is determined only at the time of launching and not manufacturing. And not manufacturing. See, there is a rocket A and there are two rocket launchers X and Y. There are two rocket launchers X and Y. The same rocket A can be maybe launched to a range of 30 kilometer by X and maybe 100 kilometer by Y. So the same rocket A can be used, can be launched to two ranges by the rocket launcher. So the range of a rocket will be decided only at the time of launching and not at the time of manufacturing. So not at the time of manufacturing. For missiles, it is decided at the time of manufacturing itself. Whereas for rocket, it will be decided at the time of launching. For rockets, the range will be decided at the time of launching. Okay. So now we'll discuss the missiles in detail. Next is the classification of missiles. Classification of missiles. So missiles can be classified into 5 heads. First classification is based on pathway. Based on the pathway of a missile. So based on pathway, missiles can be classified into ballistic missiles and cruise missiles. Ballistic missiles and cruise missiles. First is based on the pathway. Second classification is based on the range. The range of the missile. So range is more specifically used for ballistic missiles. Cruise missiles, we are more concerned about the speed of cruise missiles. Range is more mentioned for ballistic missile. So there is short range ballistic missile, which is called SRBM. There is short range ballistic missile. Then there is medium range ballistic missile. Then there is intermediate range ballistic missile. And long range ballistic missile, or it is also called intercontinental ballistic missile, LRBM. So intermediate range is called IRBM. Long range ballistic missile or intercontinental ballistic missile. Intercontinental ballistic missile, ICBM. So we'll discuss about all this, different ranges when we discuss. See, Agni 5 is an example of intercontinental ballistic missile. We'll discuss India's all missiles. So there we'll discuss about all this. Which are the short range missiles, which are the long range missiles, which are the medium range missiles. All these things will be discussed. Okay. So short range is there, medium range, intermediate range, and then the long range. Now, third classification is based on speed. Based on speed, it can be classified into subsonic cruise missiles, supersonic cruise missiles, and hypersonic cruise missiles. Subsonic, supersonic, and hypersonic. Third is based on speed, can be classified into subsonic, supersonic, and hypersonic. Done? Done? Anybody wants me to wait? Okay. So the fourth classification is based on the target of the missile. Fourth classification is based on the target. So based on target, there can be anti-ballistic missiles, anti-ballistic missiles, anti-cruise missiles, anti-aircraft missiles, anti-ship missiles, anti-tank missiles, then there can be anti-personnel. Even now you have anti-satellite missiles. So all this is examples of missiles based on the target. Anti-ballistic, anti-cruise, anti-aircraft, anti-ship, anti-tank, anti-personnel, anti-satellite, etc. And the last classification is based on area of operation. Area of operation. Based on area of operations, missile can be classified into surface to surface, surface to air, air to surface, and air to air. So these are the classifications of missiles based on pathway, range, speed, target, and area of operation. Next, so first we'll discuss all this one by one. First we'll discuss ballistic missiles. Ballistic missiles. So ballistic missiles are surface to surface missiles. Surface to surface missile. Ballistic missiles are surface to surface missiles. And they need to have arc shaped or parabolic movement. They need to have arc shaped or parabolic movement. So that is why it is called ballistic. So this rocket, the path of this rocket will be always arc shaped or parabolic. So this will be the shape of the path of the target, path of the missile. So that is why it is called ballistic missile. It should have an arc shaped or parabolic movement. It should have an arc shape or parabolic movement. Now, how will you analyze? So, as I told, it is a surface to surface missile. So, if you analyze the pathway of the missile, okay, if you analyze the pathway of the missile, so the missile will have three phases of movement. The missile will have three phases of movement. The missile will have three phases of movement. A ascending phase, or one ascending phase. This ascending phase will be in the atmosphere. Okay, this ascending phase will be in the atmosphere. 2 traveling phase or transition phase. 2 traveling space or transition space, which will be in the outer space. Traveling phase or the transition space will be in the outer space. And 3 the returning phase or the striking phase, which will again be in the atmosphere. The returning phase or the striking phase will be in the atmosphere. It can be launched from land, floating ship, or even a submarine. Land, floating ship, or even a submarine. So for a ballistic missile, outer space travel is mandatory. Only if it travels through this outer space, it will be able to achieve this, parabolic shape, or the arc shape. Arc shape will be obtained only if it travels through the outer space. So outer space travel is mandatory. For ballistic missiles, outer space travel is mandatory. Outer space travel is mandatory. For ballistic missiles, outer space travel is mandatory. And these ballistic missiles are basically classified on the basis of their range. So ballistic missiles are classified on the basis of their range as short range, medium range, intermediate range, long range, etc. It is classified on the basis of the range as short range, medium range, intermediate range, long range, etc. So this is how ballistic missiles are classified. What is this range? We'll discuss. So short range, medium range, intermediate range, long range, they are classified in the basis of their ranges. Next is cruise missile. Cruise missile. So this is a rocket we discuss, unguided weaponry system, less precise, range is determined the type of launching, and missiles are classified into based on 5 categories. So this is a ballistic missile. So if you see, the ballistic missile always takes this parabolic shape, or the arc shape movement will be there. This all ballistic missiles are surface to surface missiles. They outer space travel is mandatory. And next is cruise missile. Cruise missile. So cruise missiles can be, so what is remaining? It can be surface to air, air to surface, or air to air. Cruise missiles can be surface to air, air to surface, or air to air. Surface to air, and air to surface. All this is possible. What about the pathway? It has a zigzag pathway. It has a zigzag pathway. This will be the pathway. It has a zigzag pathway. So ballistic missiles have an arc-shaped pathway. In cruise missiles, we have a zigzag pathway. The maximum height at which a cruise missile can fly, the maximum height at which a cruise missile can fly is 3 kilometers. Is 3 kilometers. So even if it is an air-to-air missile, so we are launching air-to-air missile means we are launching it from an aircraft. Okay, surface means we are launching it from land, ship, or say submarine. But here air-to-air missiles, we are launching it from an aircraft. It is targeting some other aircraft. Okay, even then the target maximum height can be 3 kilometers. Even in what we say air-to-air missiles, the maximum height it can target is 3 kilometers. So maximum height a cruise missile can fly is 3 kilometers, even in air-to-air missiles. Even in air-to-air missiles. Even in air-to-air missiles. So 3 kilometers maximum height means it is an exclusive atmospheric missile. Cruise missile is an exclusive atmospheric missile. There is no outer space travel. It is an exclusive atmospheric missile. There is no outer space travel. So all the 3 phases, ascending phase, traveling phase, and the returning phase, all these 3 is in the atmosphere. So it is an exclusive atmospheric missile, and there is no outer space travel. There is no outer space travel. And it is also called a tree-top missile. It is also called a tree-top missile. Why it is called a tree-top missile? Because it flies at the height of a treetop. Maximum height it can fly is 3 kilometers. So normally it flies at the height of a treetop. It is a zigzag missile. It is not a parabolic missile. It will go up and then it will fly at the height of a treetop. So it is called a tree-top missile. Tree-top missile. It's called a tree top missile as it flies at a height of a tree top. As it flies at the height of a tree top. And basically, cruise missiles are classified based on their speed. They are classified based on their speed as subsonic, supersonic, and hypersonic. Subsonic, supersonic, and hypersonic. So this is the classification based on pathway, ballistic missile and cruise missile. We will come into lot of examples of these missiles. Now next is the classification based on range, right? Next, what discussed is the classification based on range. So first we had short range ballistic missile. So what is this short range? So short range is when the missile travels less than 1500 kilometers. When the missile travels less than 1500 kilometers, it is called a short range missile. Medium range. Medium range is when the missile travels between 1500 to 2500 kilometers. So if the range is between 1500 to 2500 kilometers, it is called a medium range missile. And then we have intermediate range missile. Intermediate range, when the range is between 2500 to 5000 kilometers. It is called an intermediate range missile. And then long range ballistic missiles or intercontinental ballistic missiles. The range will be greater than 5000 kilometers. So when it travels more than 5000 kilometers, it will be able to strike a target in another continent. So that is why it is called intercontinental ballistic missile. So ICBM, the range will be greater than 5000 kilometers. So this is how missiles can be classified based on the range as short range, medium range, intermediate range, and long range or intercontinental ballistic missile. 1500, 1500 to 2500, 2500 to 5000, and greater than 5000 kilometers. Now, based on speed. So based on speed, missiles are classified as subsonic, supersonic, and hypersonic, right? So here we discuss about the speed on the basis of a number called Mach number or Mach. Do you know what is Mach? Have you heard about the term Mach? What is Mach? Any idea? Mach number. No idea? So Mach is, yes. So Mach is speed of the object as compared to speed of sound. Speed of object as compared to speed of sound. So when I say Mach is equal to 1, when I say Mach is equal to 1, that means the object is moving at the speed of sound, right? So speed of sound. So when Mach is 1, speed of object is equal to speed of sound. So Mach is speed of object by speed of sound. So when I say Mach is equal to 1, that means speed of the object will be equal to the speed of sound. So in subsonic, the Mach will be less than 0.8. So here it will be, Mach is represented by M. So it will be less than 0.8. In subsonic, the speed of the missile will be less than 0.8 times the speed of the sound. Okay, so it is not traveling at a faster speed. In supersonic, the Mach will be between 1.2 to 5. And in hypersonic, it will be between 5 to 10. So supersonic, the Mach will be between 1.2 to 5. And in hypersonic, it will be between 5 to 10. So this is the classification based on speed. Next is the classification based on target. Next is the classification based on target. So we discuss the names. First is anti-ballistic missiles. First is anti-ballistic missiles. First is anti-ballistic missiles. Now what are anti-ballistic missiles? Ballistic missiles capable to intercept incoming enemies ballistic missiles capable to intercept incoming enemies ballistic missile at any desired altitude. So what is this intercept? Interception meaning to catch and destroy. If you catch and destroy something, it is called interception. So any ballistic missile which is capable to catch and destroy incoming enemies ballistic missiles. So generally ballistic missiles are launched to strike something on the ground. So anti-ballistic missiles can do what? Enemy's ballistic missile is coming. We can destroy the enemy's ballistic missile by launching a anti-ballistic missile. Okay, we're launching an anti-ballistic missile. So this is an anti-ballistic missile. Now I'll give you two statements. Tell me if it is right or wrong. All ballistic missiles are anti-ballistic missiles. True or false? All ballistic missiles are anti-ballistic missiles. True or false? Think and tell me, all ballistic missiles are anti-ballistic missiles. That ballistic missile is surface to surface missile. You can launch, then you can target something on the surface. Anti-ballistic missile is used to destroy something on the air. All ballistic missiles are anti-ballistic missiles. True or false? Okay, both true and false have come. Now, second statement I'll tell you. All anti-ballistic missiles are ballistic missiles. All anti-ballistic missiles are ballistic missiles. Two statements I gave you. Okay, all ballistic missiles are anti-ballistic missiles. All anti-ballistic missiles are ballistic missiles. Which among this is true? Both are true, both are false. One is true, one is false. This is what you have to tell me. Yes. See, all anti-ballistic missiles are ballistic missiles. All anti-ballistic missiles are ballistic missiles because what is the purpose of an anti-ballistic missile? We launch them and it destroys enemies ballistic missile. If it is not destroying enemies ballistic missile, it can target something on the ground also. That is possible. It can destroy something on the ground also. So this is possible. All anti-ballistic missiles are ballistic missiles. Now all ballistic missiles are not anti-ballistic missiles because if a ballistic missile has to become an anti-ballistic missile, it should be capable of doing the interception. It should be capable of catching the enemy's ballistic missile and destroying the ballistic missile. All ballistic missiles cannot do it. The basic purpose of a ballistic missile is targeting something on the ground, right? So if it has to destroy something on the air, it should have some special capabilities. So all ballistic missiles cannot be anti-ballistic missiles. But all anti-ballistic missiles are ballistic missiles. If it is not able to destroy on the ground, it can destroy something on the, it is not able to destroy something in air, it can destroy something on the ground also. That is possible. Okay, the other way around is not possible. So all anti-ballistic missiles are ballistic missiles. All anti-ballistic missiles are ballistic missiles, but not vice versa. But not vice versa. That is, all ballistic missiles cannot be anti-ballistic missiles. That is, all ballistic missiles cannot be anti-ballistic missiles because all ballistic missiles cannot do interception. Because all ballistic missiles cannot do interception. Because I'll repeat, because all ballistic missiles cannot do interception. What is an anti-ballistic missile? See, the purpose of a ballistic missile What is the purpose of a ballistic missile? Ballistic missiles are surface to surface missiles. So I have a I have a ship here. I am launching a ballistic missile and I am destroying the ship or submarine or something on the land, a military tank, whatever. I am destroying something here. Okay, so this is a ballistic missile. It will take parabolic path and then it will destroy something on the ground, on the surface. Okay, so it can travel even up to greater than 5,000 kilometer. It can travel long range. It can travel. Now, in an anti-ballistic missile, what will happen? So I am launching an anti-ballistic missile. So an enemy's ballistic missile is coming. Okay, an enemy's ballistic missile is coming. My anti-ballistic missile will destroy the enemy's ballistic missile. It will catch and destroy enemy's ballistic missile at any altitude. At any altitude, it can be destroyed. So I am launching a ballistic missile from here. So enemy's ballistic missile is coming and it has already reached this much. It is already in the atmosphere. By using a ballistic missile, I can destroy it here, or I can destroy it even in outer atmosphere. So at any place I can destroy this enemy's ballistic missile. But enemy's ballistic missile will not be able to destroy my anti-ballistic missile because all ballistic missiles do not have this capability. If enemy's ballistic missile is also an anti-ballistic missile, both ballistic missiles will be destroyed. Okay, so here I am trying to destroy enemy's ballistic missile by sending an anti-ballistic missile. So this is the concept of an anti-ballistic missile. Clear? So all anti-ballistic, suppose I am launching an anti-ballistic missile, no, but there is no enemy's ballistic missile. I am launching an anti-ballistic missile. There is no enemy's ballistic missile. It can target something on the ground also, surface also. This is also possible. So that is why I told all anti-ballistic missiles are ballistic missiles. But if you want to do this interception, it should have some capabilities. All ballistic missiles will not be able to do this. Clear? Is this clear? Somebody asked me to repeat. So next is anti-cruise missiles. So from the name itself, what is an anti-cruise missile? Anti-cruise missile is a cruise missile. It is a cruise missile which is capable to intercept the incoming cruise missile. Which is capable to intercept the incoming cruise missile within the atmosphere. So it is capable to intercept the cruise missile within the atmosphere at a height of 3 kilometers. Within the atmosphere at a height of 3 kilometers. So here there is no, it is not at any altitude. So this cruise missile is capable to be capable to travel at a height of 3 kilometers only. So within 3 kilometers it can be destroyed. Within a height of 3 kilometers it can be destroyed. Okay, so this is an anti-cruise missile. Now we have an anti-aircraft missile, anti-ship missile, anti-tank missile. Right, we discussed different types. The only difference here is the target. The target will keep on changing. So in an anti-aircraft missile, the target will be an aircraft. In an anti-ship missile, the target will be a ship. In anti-tank missile, the target will be a military tank. In anti-personnel missile, the target will be the infantry, people, infantry. Then there is anti-satellite. Anti-satellite missile where the target is a satellite. So these are the various classifications based on the target. Based on the target. Aircraft, ship, tank, personnel, satellite, etc. The target, just the target will vary. So if you destroy an aircraft, it is an anti-aircraft. Destroying a ship, anti-ship. Destroying a military tank, anti-tank. Destroying people, it is anti-personnel. Destroying infantry, destroying satellite is anti-satellite. So all this is different classification of missiles based on target. Now the final target classification is based on the area of operation, right? Again, now it will be very easy. What is area of operation? It is classified into surface to surface, surface to air, air to surface, and air to air. So this is a classification. So what is a surface to surface missile? Surface to surface missile will be a ballistic missile. The rest three will be cruise missiles. So if it is a surface to surface missile, it will be a ballistic missile. The rest three, surface to air, air to surface, air to air, all of them will be cruise missiles. So this is a classification of missile. This is the classification of missile. Done? Done? So again, anti-aircraft missile, it can be anti-aircraft missile, it will be cruise missiles, because ballistic missiles are surface to surface missiles. It cannot be used to destroy an aircraft. See, anti-ship missiles, it can be both. It can be ballistic missile and cruise missile, because cruise missile is, you see, there is air to surface missile. It can be launched from air, it can target a ship. Surface to surface missile, it can be launched from ground and then it can target a ship. So military, it can be both ballistic and cruise. Military tank missiles, it can be both ballistic and cruise. So it varies, it depends. So if you want to destroy an aircraft, it will be a cruise missile, because ballistic missiles will not be able to destroy aircrafts. Fine. Now next is steps involved in launching a missile. Steps involved in launching a missile. So there are 6 steps which are there, which is involved in launching a missile. Again, is the screen becoming blurred? Fine. No? Okay. On and off. If at all you are facing any issues, please let me know, because I am not really looking into the board. I mean into the screen. Okay. So there are 6 steps which are involved in launching a missile. So first step is called stacking. There is stacking, then there is assembly, then there is loading, then there is positioning, then there is targeting, and then there is attacking or firing. So these are the 6 steps involved in launching a missile. Now, why I discussed all these steps is more than the steps involved. We have to study about the classification, generations of missile. Okay, that is why I discussed these steps. So stacking is basically arranging the missile in the manufacturing sector. Okay, when you are manufacturing a missile, the process of arranging there, it is called stacking. So this is done in the manufacturing sector. Now assembly is done in the battlefield. So assembly is done in the battlefield. In the battlefield, you bring the different components of a missile and assemble it. It's called assembly. Now, loading, positioning, from the term itself, you load a missile, you position it, the target, etc. Then you will target and then you will fire. These are the different steps. The first two steps, stacking and assembly, is always done manually. This is always done manually. Now, these four steps, is done in different manner based on the generation of missile. So, in the first generation of missile, okay, first generation, all these four steps are done manually. In the second generation of missile, so this is first generation. In the second generation of missiles, don't write, I'll give you the notes. In the second generation of missile, loading and positioning is done manually, and targeting and firing is done automatically. In the third generation of missiles, all these four steps are done automatically. Okay, so these two steps are done manually in all these three generations, but loading and positioning is done automatically in the third generation. In second and third generation, targeting and firing is done automatically. All these 6 steps are done manually in the first generation. So this is the classification of missiles based on the generations. So there is a name given to all this generation. First generation, where we do all these steps. First generation where we do all these steps manually is called manually controllable line of sight. Second generation where we do 2 steps as automatic is called semi-automatic controllable line of sight. And where we do all these 4 steps automatically is called automatic controllable line of sight. So there is manual controllable line of sight, semi-automatic controllable line of sight, and automatic controllable line of sight. Okay, so you can just take down these steps. First you write steps involved in launching a missile. Steps involved in launching a missile: stacking, assembly, loading, positioning, targeting, firing. These steps you take down. Now, stacking is done in the manufacturing sector. While the missile is getting assembled, the process is called stacking. And assembly is done in the battlefield. Stacking is done in the manufacturing. Assembly is done in the battlefield. Both stacking and assembly is always done with the help of human beings, or both stacking and assembly is always done manually. Both stacking and assembly is always done manually. It is always done manually. Now you just give a subheading: generation of missiles. Generation of missiles. First generation. First generation. It is called MCLOS. MCLOS, manually controllable line of sight. 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 All the 6 steps. All the 6 steps in launching a missile. All the 6 steps in launching a missile are done manually. All the 6 steps in launching a missile are done manually. Second generation. Second generation. Second generation missile are called SACLOS, semi-automatic controllable line of sight. Semi-automatic controllable line of sight. Second generation is SACLOS, semi-automatic controllable line of sight, where step 5 and 6. Step 5 and 6 is automatic. Step 5 and 6 is automatic. That is, targeting and attacking is automatic. Step 5 and 6 automatic. Targeting and attacking is automatic. Rest all is manual. Then third generation is called automatic controllable line of sight. Third generation is automatic controllable line of sight, where all steps from step 3 to 6, all steps from step 3 to 6 is automatic. Loading, positioning, targeting, attacking, all these 4 steps are automatic. So these are the steps involved in launching a missile as well as the generations of missile. So missiles can be classified into 3 generations. First generation, manual controllable line of sight. All the steps in launching a missile is done manually. In the second generation, the targeting and attacking is done automatically. And in the third generation, 4 steps are done automatically. Next is selecting a target for the missile. Selecting a target for the missile. So there are 2 ways by which we can select a target. Okay, so there are 2 ways by which, there are 2 ways by which we select a target. First one is called LOBL. LOBL, it is lock on before launch. First is LOBL, lock on before launch, and second is called LOAL, that is lock on after launch. Lock on before launch and lock on after launch. LOBL and LOAL. So from the name itself, what is LOBL? We lock the target before the missile is getting fired. Okay, we lock the target. What is the target? Before launching itself, we lock it and we'll fire it. So this is LOBL, lock on before launch. Lock on before launch. The target is fixed before launch itself. The target is fixed. The position of the target is fixed before launch itself. And LOAL is lock on after launch. Lock on after launch. The position of the target is fixed. The position of the target is fixed after launch of a missile. The position of target is fixed after launch of a missile. The position of a target is fixed after launch of a missile. So these are the, one more thing I want to tell you. Lock on before launch. Okay. So lock on before launch is mostly preferred for a static target. So if the target is fixed somewhere, we will decide the position of the target beforehand and launch it. Generally, not always. Okay, not always. Generally, it is fixed for a static target. And lock on after launch is used for a moving target like an aircraft, etc., which will keep on moving. We will fix the location only after launching, because initially if we fix the location and fire it, it might not strike accurately. Okay, so this is lock on after launch is generally used for a moving target or a dynamic target, and lock on before launch is used for a static target or a fixed target. Not always. We can use LOBL even for a moving target if we have the enough technologies to do that. So there should be a mounter, etc., where we can actually launch it in such a way that it will strike a moving target. Possible. It is possible, but generally preferred for static target, dynamic target. Okay, so generally preferred for a static target, that is a fixed target, dynamic target, or moving target like aircrafts. So this is how you select a target based on the how you select a target for the missile. Next is India's missile development program. So we discussed about cruise missiles. Then we discussed about the steps involved in launching a missile, and I discussed about the generations of missile. Next is India's missile development program. India's missile development program. It is about the the target, where to strike the target, the position of the target. So we will fix the target. See, missile is basically launching a target at a particular position. Okay, so where, when it will be fixing the target, before launching itself you will know that this is the exact position where we have to strike. So that is lock on before launch, and after launch we'll fix the target, then it will be lock on after launch. Okay, any other questions? Maybe we'll move to India's missile development program after the break, next session. Any questions if you have, please ask. So far, any issues, any questions? Pace of the class is fine. Are you able to understand what we are discussing? Speed. Speed of the class is okay. Are you able to understand what we are discussing? Fine. Any issues if you are facing, please do tell me. Any issues you are facing in the class? Dictating notes, taking what I'm writing in the board. Any issues if you are facing, please do tell me very openly. There is no problem at all. Fine. Thank you. So we'll take a break. I think your next session is at 5, right? So 5 o'clock, we'll continue with India's missile development program. Sir, please make me co-host. Okay. So we will start with India's missile development program. Which organization is in charge of our defense development? Which organization takes care of our defense development? Which organization in charge of our defense development, or which organization takes care? Yes, DRDO, Defense Research and Development Organization. So DRDO is India's missile development program, done by DRDO, Defense Research and Development Organization. Defense Research and Development Organization. So we started our, we started to develop our defense technologies or missile technologies in the 1960s. So in the 1960s, DRDO had a project called Project Indigo. So there was a project called Project Indigo, and DRDO tried to develop some surface to air missiles. In this Project Indigo, DRDO tried to develop some surface to air missiles, but without achieving full success, we had to discontinue this program. So this Project Indigo happens in the 1960s. In 1970s, DRDO runs two projects parallelly. There is Project Devil and Project Valiant. There are two projects which are done by DRDO simultaneously, Project Devil as well as Project Valiant, in which again DRDO tries to develop ballistic missiles, surface to air missiles. They try to develop ballistic missiles, surface to air missiles, etc. in both these projects. Okay, so Project Devil and Project Valiant, two projects are run simultaneously. They try to develop ballistic missiles, surface to air missiles, etc. Now what happens is both these projects will fail. Now when a project fails in defense, or we call it a technology demonstrator project. We do not call it a failed project, but rather it is a technology demonstrator project where we tested a technology. This is called a technology demonstrator project. So both this Project Devil as well as Project Valiant can be called as technology demonstrator projects. And basically it failed because of the internal feuds in DRDO. There was a lot of superior subordinate conflicts in DRDO, and because of that both these projects, Project Valiant and Project Devil, both of them failed in the 1970s. So this way until 1960s we tried to develop missiles, we failed. 1970s we tried to develop missiles, we failed. In 1984, under India's first woman defense minister, who was India's first woman defense minister? Any idea who was India's first woman defense minister? Any idea? India's first woman defense minister. Who's it? Or rather, who was it? Anybody knows? So India's first woman defense minister was Indira Gandhi, and Indira Gandhi started a mission called Integrated Guided Missile Development Program, IGMDP. Integrated Guided Missile Development Program, IGMDP. So there is a very young man who was, who had a lot of ideas, who wanted to do a lot of things in the defense research. So Indira Gandhi gave the charge of this mission to this very young man. Do you know he's a very popular person? Yeah, sure. Where did you lack? Did you get about Project Indigo? Did you Project Devil? See, these are all like initial projects of DRDO, not very relevant. I just told you some history. See, Project Indigo, DRDO tried to develop some surface to air missiles. Okay, I'm just telling you some history. Then Project Devil and Valiant was happening in the 1970s. So again, both these projects failed. We tried to develop ballistic missiles, we tried to develop surface to air missiles, everything failed. In 1984, so yes, Indira Gandhi was the defense minister, and a young man was given the charge of this mission called APJ Abdul Kalam. He is the missile man of India. So Indira Gandhi gave the charge of this mission, Integrated Guided Missile Development Program, to Abdul Kalam. So under Abdul Kalam, we started developing missiles. Okay, and this mission was a huge success. We could develop a lot of missiles under this program, Integrated Guided Missile Development Program. This is also called like IGMDP. In short, we call it as IGMDP. So this is the program under which India develops all its major missiles, IGMDP, Integrated Guided Missile Development Program. Now, what was the main mission of this missile? We wanted to be self-sufficient. Obviously, that is what indigenization. We wanted to be self-sufficient in the production and development of ballistic missiles. So the main aim was ballistic missiles, but we developed both ballistic and cruise missiles. Our main aim was to be first develop our own ballistic missiles, but we developed ballistic and cruise missiles. There are 5 categories of missiles which were developed under this IGMDP. There are 5 categories of missiles which was developed under IGMDP. First was Akash. Akash. Second is Trishul. Akash, Trishul. Then we have Prithvi. Prithvi. Then Agni and Nag. So we developed 5 categories of missiles under this IGMDP: Akash, Trishul, Prithvi, Agni and Nag, and all of them were successful. All these missiles were successful. So first Akash and Trishul, both were surface to air missiles. Akash and Trishul both were surface to air missiles. So when it is surface to air missiles, what category of missile they will be, or what is the pathway of these missiles? When it is surface to air missiles, what will be the pathway of these missiles? Surface to air missile, then it will be what category of missiles? It will be cruise missiles. So these 2 are examples of cruise missiles. See, ballistic, remember, ballistic is always surface to surface. You launch it from a surface, it will reach another surface. Then only it can have this ballistic path. So surface to air, air to surface, air to air, everything will be cruise. So Akash and Trishul are examples of surface to air missiles, which are cruise missiles. Now Prithvi and Agni, both are surface to surface missiles. Both are surface to surface missiles. Prithvi and Agni are surface to surface missiles. So when they are surface to surface missiles, it is example of ballistic missiles. Both these are ballistic missiles. And Nag is an anti-tank missile. So Nag is an anti-tank missile. We discussed based on target missiles can be classified. So this is an anti-tank missile. Nag is an anti-tank missile. Okay, so these are the 5 successful classifications of missiles which we developed under IGMDP. Akash, we'll discuss all of these missiles in detail. We'll study about all these missiles in detail. Akash, Trishul, Prithvi, Agni and Nag. So all these were developed under IGMDP. Now, see, this project was such a success and we developed a large category of missiles so that we ended this mission by 2007. So this started in 1984 and the mission successfully completed in 2007. 2008 January, we stopped this mission. And then 2008-9 was kind of a cooling period. We did not develop any new missiles in this period. 2008-9 can be called as a cooling period. And after 2008, in 2009 onwards, we took 2 major projects. DRDO is focusing, there are multiple projects, but there are 2 major projects which are handled by DRDO. First one is called Project Black. There is a Project Black which is done by DRDO. In Project Black, we are trying to develop submarine launched ballistic missiles. We are trying to develop submarine launched ballistic missiles. So we'll discuss submarine launch. Where we have different type of submarine launch ballistic missiles like Sagariga, K4, K5. These are all examples. We are trying to develop what is submarine. Submarine is underwater. We want to launch ballistic missiles from submarines. Okay, we want to launch ballistic missiles from submarines. So Project Black is focusing on developing ballistic missiles from submarines. Submarine is also a surface. So ballistic missiles surface to surface include submarines also. This is what Project Black is focusing. Then we have Project BrahMos. Second major project is Project BrahMos. Project BrahMos. So Project BrahMos, India and one more country is collaborating. Which country? You might have heard about. Yes, Project BrahMos is India and Russia. Project Indigo. You want to repeat? I'll repeat. So Project BrahMos is a collaboration of India and Russia. So this BrahMos is the name of two rivers. No, they have mixed two rivers, Brahmaputra and Moskva. So Brahmaputra in India and Moskva is the river in Russia. So Moskva, the name of these two rivers were clubbed and we gave the name of BrahMos. So India and Russia is collaborating and developing BrahMos. We already developed BrahMos 1. We are going to develop BrahMos 2, BrahMos 3. Research is going on in BrahMos 1, 2, 3, etc. Already we have developed BrahMos 1. So this is another main project where DRDO is focusing. So BrahMos is world's largest supersonic cruise missile. So BrahMos is world's largest supersonic cruise missile. This is the world's largest supersonic cruise missile. And India and Russia have developed this world's largest supersonic cruise missile. See, Project Indigo is the first project which DRDO took up in the 1960s. We wanted to develop surface-to-air missile. DRDO wanted to develop surface-to-air missiles. This project was taken up in 1960s. The project was not a success. That's all. First project which DRDO took up, Project Indigo. DRDO tried to develop surface-to-air missiles. That's all. And the project was not a success. After that, they took Project Devil and Project Valiant. Both did not succeed. Finally, in 1984, we launched IGMDP, where we developed all the 5 missiles I told you, and it was a huge success. Okay. So I don't think they will ask about Indigo, Devil and Valiant, etc., because they are outdated projects, old projects. But just to understand, I told you the history. That's all. Fine. This is the crux of India's missile development program. Now we will discuss the major missiles of India. Okay, we'll discuss the major missiles of India. First, we will see air-to-air missiles. Air-to-air missiles. First is air-to-air missiles. In air-to-air missiles, first we will discuss about this missile Astra. Astra. Missile Astra. So again, when it is a air-to-air missile, what is the pathway of the missile? Air-to-air missile is, what is the pathway? Air-to-air missile will be cruise missile, right? Air-to-air missile will be cruise missiles. So it is a kind of cruise missile. Air-to-air missile will be a kind of, all air-to-air missiles will be cruise missiles. All air-to-air missiles will be cruise missiles. Yes, cruise. Zigzag pathway, cruise. So first one is Astra. Astra is a short range air-to-air missile. Short range air-to-air missile. Short range air-to-air missiles. It comes under the category of beyond visual range air-to-air missile, BVRAM. beyond visual range air-to-air missiles. Beyond visual range air-to-air missiles. So this Astra is called a BVRAM, beyond visual range air-to-air missiles. Now, if you want to visibly see a missile in the air, now how will we detect that a missile is going in the atmosphere? What is the way to visually detect? You can detect it using radar, etc. That is different. I'm asking how we can visually see that in the atmosphere some missile is moving. How we will identify it? We can identify it using how we can visually identify it. Do you know any idea how we can visually identify a missile which is going in the air? Especially cruise missile is going at a height of 3 kilometers. So if at all, no, I'm not asking telescope. Visually, you have to see with eyes. So the way to see it is the smoke. No, when the missile is moving, you will obviously see smoke in the air. So when we say beyond visual range air-to-air missile, that means it is a smokeless propellant or there is no evidence of the missile. So BVRAM, beyond visual range, means it uses a smokeless propellant. It uses a smokeless propellant. It uses a smokeless propellant. There will be no evidence of the missile movement. There will be no evidence of the missile movement. There will be no evidence of the missile movement. And hence, we will not be able to we will not be able to track it with visual. We will not be able to track it with normal vision. We will not be able to track it with normal vision. And hence we will not be able to track it with normal vision. Then it is a single stage solid propellant missile. Single stage solid propellant. So it is just a solid propellant and the burning happens in a single stage. So it is a single stage solid propellant missile. Single stage solid propellant missile, and it is also called LLQRM. LLQRM. What is LLQRM? Low level quick response missile. This is also a low level quick response missile. Low level quick response missile. Astra is also called a LLQRM, low level quick response missile. Why low level and why quick response? See, low level, it is a cruise missile. What is the maximum height it can travel? It is at 3 kilometers, right? So it travels at a maximum height of 3 kilometers. That is why it is called low level missiles. And quick response missile because it can strike the target in 6 seconds. It can strike the target in 6 seconds. And that is why it is called quick response missiles. Strike the target in 6 seconds. And low level because the maximum height is 3 kilometers. Maximum height is 3 kilometers. So low level and quick response because it strikes the target in 6 seconds. It is also called a fire and forget type missile. It is also called a fire and forget type missile. Fire and forget. So what is this fire and forget? LOBL. Missiles are called fire and forget type missiles. LOBL. What is LOBL? LOBL is lock on before launch. So before launching itself, you will decide what is the target or where is the target. So before launching, you will decide where is the target and then you will launch it. That is lock on before launch. We discussed this. So all LOBL missiles can be called fire and forget, because you fire, then you can forget about the missile because it will automatically go and strike the target. You do not bother about it after firing. Whereas in LOAL, you actually decide the target's position after firing. So you have to, you have to control it or you have to maneuver it even after firing. Whereas in LOBL, you fire, forget. So this is also called a fire and forget type missile. It is also called a fire and forget type missile. That is, it is based on LOBL, lock on before launch. Lock on before launch. See, it is an air-to-air missile. I told you, it is an air-to-air missile. That means it is going to target an aircraft, something in the air. So that means it will be moving, right? Even if it is moving, we are using LOBL, not LOAL. So some special platform is required for doing this LOBL and target a moving target. We will have some special, special platforms which will be provided, whereby Astra can target even a moving target. Astra, even though it is LOBL, it can target a moving object. Okay. Then it is used by Air Force. It is used by both Air Force and Navy. It is used by both Air Force and Navy. It is used by Air Force and Navy, and it is an indigenous missile. Astra is an indigenous missile. So we have developed it by ourselves. Astra is an indigenous missile. Astra is an indigenous missile. And see, it is an air-to-air missile. So we require an aircraft to launch this missile, right? It can be launched from an aircraft. So Astra is capable of being launched from two aircrafts. Astra is capable of being launched from two aircraft. Which are these aircrafts? Sukhoi 30 MKI and Tejas. So these are the two aircrafts from which we launch Astra. Astra can be launched from two aircrafts, Sukhoi 30 and Tejas. Sukhoi 30 and Tejas. Sukhoi 30 and Tejas. We'll discuss about aircrafts. After this, I'll just show you this missile. So this is Astra. We discuss cruise missile. It is a short range air-to-air missile. BVRAM, beyond visual range air-to-air missile. LLQRM, quick response missile. Then it is low level quick response missile, fire and forget type missile, right? I'll just show you Astra's. So this is Astra. This is Astra launch from Sukhoi 30. So this aircraft is Sukhoi 30 and we are launching it from air. So DRDO testing the Astra missile. And this aircraft is the Sukhoi 30 MK. So it is India's first indigenous air-to-air missile. It is India's first indigenous air-to-air missile. So this is the anti-tank missile. Okay, this is not this. This is the anti-tank missile. Just club the video. So this is Astra. Astra is a short-range air-to-air missile which India has having. Now we discussed about Sukhoi 30 MKI. So Sukhoi 30 MKI, we can again write some features of Sukhoi 30 MKI. Sukhoi 30 MKI. Sukhoi 30 MKI is a fourth generation fighter aircraft. Fourth generation, we'll discuss the generations. It is a fourth generation fighter aircraft. It is a fourth generation fighter aircraft. Sukhoi 30 is a fourth generation fighter aircraft, and it has the presence of advanced stealth technology. It has the presence of advanced stealth technology. It has the presence of advanced stealth technology. So what is the stealth technology? Stealth technology means it is a low observable technology. That is, You will not be able to detect this aircraft using radar, sonar, etc. That is called stealth technology. So this can be applied not just to aircraft. We can make ships, submarines. All these things can be made not visible to radar, sonar, etc. This is called low observable technology or stealth technology. We will be discussing the different ways by which you can make something stealth. Stealth means it is a low observable technology. So it has advanced stealth technology. It has advanced stealth technology, which is a low observable technology. Low observable technology. It is a low observable technology. Low observable technology, or it will be less visible. It will be less visible to detection methods. It will be less visible to detection methods like radar, sonar, etc. It will be less visible to detection methods like radar, sonar, etc. It will be less visible to detection methods like radar, sonar, etc. It can be applied to aircraft. It can be applied to aircraft, ships, submarines. It can be applied to aircraft, ships, submarines, missiles, etc. Submarines, ships, missiles, etc. All of them can be mailed stealth. So this is actually a main topic. Stealth technology. What are the different types of stealth technology is a main topic. We'll discuss that later. Different types of stealth technology. But just understand, Sukhoi 30 has this stealth feature. Then third, it has onboard refueling system. It has onboard refueling system. It has onboard refueling system, or it has onboard refueling facility. What is onboard? See, generally, if you want to refuel an aircraft, we have to bring it to the ground and refuel it, right? Onboard refueling means in the sky itself, you can refuel it. You can bring another aircraft, and from this another aircraft, you can refuel this aircraft. So you need not bring it to the ground. In the air itself, you can refuel it. So this is called onboard refueling system. So it has onboard refueling system. This capability is there. Onboard refueling system. Then it has seating arrangement for two pilots. Two pilot seating arrangement. It has two pilot seating arrangement. See, basically this two pilot seating arrangement is there for civilian aircraft. Civilian aircraft has two pilot seating arrangement. In a military aircraft, there is generally seating arrangement only for one person. But Sukhoi 30 MKA has a seating arrangement of two persons. So when one is flying the aircraft, another one can launch missile. So this is all part of fourth generation fighter aircraft. Okay, I told you this is a fourth generation fighter aircraft. These features are there for all fourth generation fighter aircraft. Sukhoi 30 has also this feature. So, and it is capable of, it has something called dogfight capacity. It has a dogfight capacity, or it is capable of doing dogfight. It has a capacity to do dog fights. Now, what is this dog fights? In dog fights, it can come to this enemy's aircraft as close as possible. So this is a dog fight. It can come up to 500 meters near the enemy's aircraft and then attack it. So it is capable of dog fight, that is attacking the enemy's aircraft, in the closest manner. Attacking the enemy's aircraft in the closest manner. Attacking the enemy's aircraft in the closest manner. Minimum distance of 0.5 kilometer. Minimum distance of 0.5 kilometer. Minimum distance of 0.5 kilometer with respect to enemy's aircraft. Minimum distance of 0.5 kilometer with respect to enemy's aircraft. So all these are features of the Sukhoi 30 MKA, which is a fourth generation fighter aircraft. Now we have our own. This is no Sukhoi 30 MKA we got from Russia. This is a Russian aircraft. The Sukhoi 30 is a Russian aircraft, and we brought it from Russia. Belongs to Russia. We have our own indigenous fourth generation aircraft. The name we already discussed, which is Tejas. So Tejas is India's own fourth generation aircraft. Tejas is India's own fourth generation aircraft. This is our indigenous aircraft. So Astra can be launched even from Tejas. So Astra can be launched. This is only under testing. We have not used it. This is testing is going on. We have not commissioned it. Commissioning is only when we start using it in the Army, Navy, Air Force. It is called commission. So this is still under the testing phase. And this Tejas uses an indigenous aircraft called Kaveri engine. This uses an indigenous engine called Kaveri engine. So Tejas uses an indigenous engine called Kaveri engine. It uses an indigenous engine called Kaveri engine. So this is the Tejas. So Sukhoi 30 MKA, I discussed. It has advanced stealth technology. It has onboard refueling facility, capable of dogfights, two-seater pilot alignment, etc. So this is the Sukhoi 30 MKA, and this is Tejas. It is an Indian aircraft. It is under testing. It is also a fourth generation aircraft. Now we'll discuss, because we were discussing about aircrafts, we'll discuss the different generations of aircrafts. Different generations of aircrafts. Just I'll club with this and discuss the different generations of aircraft. Aircraft will come under which category? Aircraft will come under which category? Where did we discuss aircrafts? Beginning, we discussed where did we put aircrafts? Aircraft was part of the patrolling system. Okay, aircraft was part of the patrolling system. So I am just discussing one aspect of patrolling system here. What is aircraft? So aircraft, there are five generations of aircrafts. Okay, 5 generations of aircraft is there. First generation, we'll discuss. We'll go through each generation. First generation, there is no radar or no navigation instrument in the first generation aircraft. There is no radar. It does not have a radar. It does not have navigation instrument. It does not have a radar. It does not have a navigation instrument. The attack is done with the help of machine guns. If this aircraft want to attack, the attack is done with the help of machine guns. The attack is done with the help of machine guns. And the mode of control. How do you control this aircraft? The mode of control is manual. The mode of control is manual. Example of first generation is this MiG-15, MiG-17. All of them belongs to Russia. So this is an example of first generation aircraft. MiG-15, MiG-17, etc. are examples of first generation aircraft. So there is no radar, no navigation instrument. The attack is done using machine guns. Mode of control is manual, and example is MiG-15 and MiG-17. MiG-15 and MiG-17. This is the example of first generation. Now second generation. Second generation aircraft. It has a radar but no navigation instrument. There is radar. It has a radar but no navigation instrument. But no navigation instrument. Mode of control is mechanical control. Mode of control is mechanical. First one was manual. Here we move to mechanical control. It can deal. What are the weapons? It can handle machine guns. It can handle machine guns and conventional weapons. Machine guns and conventional bombs. That is, it is not capable to handle any nuclear bombs. It is capable to handle only conventional bombs, no nuclear bombs. No nuclear bombs. It can handle machine guns, conventional bombs, no nuclear bombs. Example is MiG-19, MiG-21, MiG-19, MiG-21 are examples. Have you heard about MiG-21 anywhere? MiG-21. Last year it was in news, MiG-21. Where was it in news? Anywhere did you read about MiG-21? Yes, good. So this Abhinandan Vardhaman, who was caught by this Pakistan, he was actually flying a MiG-21. So when he was caught by this Pakistan, he was flying a MiG-21. So that is why MiG-21 was in news last year. So we are still using. See, this is all kind of outdated MiGs, but still we are using it. There is mechanical control. It is second generation aircraft. Fifth generation has come, but still India is kind of using the second generation aircrafts. So this is second generation. Next is third generation. Third generation aircrafts. So it has both radar and navigation instrument. Both are there. Radar is there. Navigation instrument is there. Radar is there. Navigation instrument is there. Mode of control is pneumatic control. Mode of control is pneumatic, or you control it using air pressure or air control. Pneumatic or air control. That is a mode of control. It can handle conventional bombs, nuclear bombs, and conventional missiles. It can handle conventional bombs, nuclear bombs, and conventional missiles. Third generation, conventional bombs, nuclear bombs, and conventional missiles. Even it can handle laser guided bombs. It can even handle laser guided bombs. Conventional bombs, nuclear bombs, laser guided bombs, conventional missiles, all this can be handled. All this can be handled. It has basic stealth features. It has basic stealth feature. It has basic stealth features. See, we discussed stealth features. Stealth feature is low visible technology. Now, how this stealth feature is getting here is, it has a slight triangular shape. So this, I'll just, one method I'm telling you, it has slight triangular shape. So when it has, this aircraft has slight triangular shape, what will happen? See, the enemy will try to detect it using radio signals. The enemy will be sending radio signals. So because of this triangular edges, what will happen? The radio signals will get scattered away. Most of the, see, if we have a shape like this, radio signals will strike all these portions and it will get lot of signals back, right? Radio signals will come back. Now, in the case of a triangular shape, not perfect triangular shape, it has slight triangular shape. So most of the radio signals will be scattered away. Since most of the radio signals will be scattered away and only a few will be deflected back. So the enemy will not be able to exactly identify this, the shape, the position, etc. of the aircraft. So this is why we said it has basic stealth feature. So in basic stealth feature, you can write it. The aircraft has slight triangle shape. The aircraft has slight triangle shape. Slight triangle shape. That means it has sharp edges. The aircraft has slight triangle shape or sharp edges. So the radio signals, that is from radar, radio signals will come, no? So the radio signals sent by the enemy country, most of the radio signals sent by the enemy country will be scattered away. Most of the radio signals sent by the enemy country will be scattered away, and only few will be detected. So this is why it has basic stealth feature. Most of the radio signals will be scattered away and only few will be detected. So example is MiG-23. Then US has an aircraft called F-4. This is all example of MiG-23, F-4. These are all examples of third generation. Next is fourth generation aircraft. So mode of control is electronic controllers. Here the mode of control is electronic controllers. It can fire any kind of weapons. So we discussed many features of fourth generation in Sukhoi 30. I told you Sukhoi 30 is a fourth generation aircraft. So all the features of Sukhoi 30 will repeat here. It has advanced stealth technology. Advanced stealth technology. It has advanced stealth technology. Onboard refueling facility. Onboard refueling facility. Two pilot seating arrangement. Capable of dog fights. And it can launch GPS guided bombs. It can launch GPS guided bomb. That is, it can hit with more accuracy. That is GPS guided bombs. It can launch GPS guided bombs. So example of fourth generation we discussed. Sukhoi 30. Is an example of fourth generation. India we have Tejas. Tejas is our indigenous fourth generation aircraft. Then there is an aircraft of France called Mirage 30. Mirage 2000. Have you heard the name Mirage 2000 anywhere? Where did we use this Mirage 2000? Anywhere in news did you read about the Mirage 2000? Did we use it anywhere? Anybody? We used it in the Balakot attacks. Okay, so in the Balakot attacks, we use Mirage 200 to drop bombs. We use Mirage 2000 to drop bombs. Now, when we did this Balakot attacks in Pakistan, we did this Balakot attacks. So we used this Mirage 2000. Then there is this F-16 of US. Then UK has a fourth generation called Jaguar. This belongs to UK. And then the aircraft which we initially planned to buy from France, Rafale 2A. So the previous government decided to buy this Rafale 2A from France. Now we did not buy Rafale 2A, we bought the advanced version of Rafale. So this was what we planned to buy initially, Rafale 2A. This Rafale 2A is also a fourth generation aircraft. Rafale 2A is also a 4th generation aircraft. Okay, this is also a 4th generation aircraft. Now after 4 comes 4.5 generation. There is one generation in between 4 and 5. There is 4.5 generation. So this 4.5 generation has all the features of 4th generation plus all the features of 4th generation plus advanced latest stealth technology. It has better stealth technology. So advanced latest stealth technology. So it is very difficult to detect a 4.5 generation aircraft. It has advanced latest stealth technology. Mode of control is electronic controllers. Mode of control is using electronic controllers. Mode of control is using electronic controllers. And it is capable of flying. It is capable of flying in extreme high altitude. It is capable of flying in extreme high altitude like the Siachen Glacier. Like the Siachen Glacier. Even in Siachen Glacier, this 4.5 generation aircraft can fly. It is capable of flying in extreme high altitude. Capable of flying in extreme high altitude like the Siachen Glacier. Like the Siachen Glacier. And the engine in 4.5 generation is called a cold start engine. It's called a cold start engine. It's called a cold start engine. That is irrespective of the external temperature, the engine will operate. Irrespective of the external temperature, irrespective of the external temperature, the engine will operate. Irrespective of the external temperature, the engine will operate. Then another feature of this 4.5 generation is it has a digital head mount display. It has a digital head mount display. It has a digital head mount display which uses augmented reality and virtual reality. Which uses augmented reality and virtual reality. Which uses augmented reality and virtual reality. That is, it integrates the physical area with the digital environment. It integrates the digital area. It integrates the digital area with physical environment. Sorry, it integrates the physical area with digital environment. It integrates the physical area with digital environment. See, what is this? We'll discuss again. This has to be studied. What is virtual reality, augmented reality, etc. But still, what happens in augmented reality? You must have heard about this game called Pokemon. Okay, so you will, when you look into the mobile phone, you will see this the area in front of you. So this classroom will be there, chairs will be there, everything will be there. But in between that, this Pokemon will jump. An obstacle will come. In the walkway, there might be a swamp. There might be water. So this is augmented reality. You mix this physical area with some digital environment. You mix, so this whatever is in front of you will be there. In addition to that, there will be extra things, and this Pokemon will be running in this area, jumping this chairs. This is augmented reality. In virtual reality, you will be in a completely different world. So you will be sitting in this room, but you will feel that you are swimming in the water. Whales are coming, and you will hear the noise of water. So this is virtual reality. You will be taken into a completely different world. So you are sitting in this room, but you will be in such a way that you are experiencing something totally different. You will forget that something is going to come and strike you. You will go back in virtual reality. This is the concept of virtual reality. So how this is, what is the use of this here? So in this display, you will simulate the place where you have to attack. Okay, so suppose you have to attack something which is 1500 kilometers away. we will be able to visualize that area in the display which is in front of you, and so that you can precisely attack it, because that is getting projected as augmented reality or virtual reality. So you will feel that you are in that area, or this area will be projected exactly in the display, so that you will be able to target objects very precisely. So this is the application of digital head mount display. Digital head mount display, where you can where you can use this augmented reality and virtual reality, and it will be capable of striking, which helps to which helps to strike the target more precisely, which helps to strike the target more precisely, which helps to strike the target more precisely, which helps to strike the target more precisely. Example of this 4.5 generation is this Rafale 3A. Rafale 3A, which we have brought from France. So now, we are purchased not Rafale 2A, but Rafale 3A we purchased. Then there is a aircraft of UK called Eurofighter Typhoon. Eurofighter Typhoon. So this is example of 4.5 generation. Eurofighter Typhoon. So these two are examples of 4.5 generation. Next is 5th generation. So 5th generation aircraft have come. 5th generation. So it has all features of 4.5 generation plus, all features of 4.5 generation plus. Mode of control will be software control. Mode of control will be software control. Mode of control will be software control, and it can operate from any terrain. Can operate from any terrain. Can operate from any terrain. Smooth, rocky water. Smooth, even rocky terrain, it can operate. See, normally if you want to fly an aircraft, there should be some runway, and then it should go in a smooth profile, then it will take off. But this 5th generation can even take off from a rocky terrain. You need not need a smooth runway to run and then fly, but even in a rocky terrain, this is capable of operating. So 5th generation, it is capable of operating even in smooth rocky terrain. It is capable to operate in any terrain. So the example of this 5th generation is C-17 Globemaster 3. There is an aircraft called C-17 Globemaster 3. C-17 Globemaster 3, which is an aircraft of USA. C-17 Globemaster 3. C-17 Globemaster 3. So India has incorporated it from USA. India has got it from USA. So India has incorporated it from USA. So this is a fighter aircraft. You can use it for fighting. But the problem is, if India want to use it for fights, we have to get an NOC from USA. Okay, first USA should give us a non-objection certificate. Then only we will be able to use it. Okay, so currently we are not using it as a aircraft for warfare, but rather we are using it as a transportation vehicle. It is used as a strategic transportation vehicle because this is a pretty big vehicle. It can lift 2,500 soldiers at one time. Okay, it can lift 2,500 soldiers. It can carry 50 military tanks in a partially dismantled condition. It is capable of carrying 2,500 soldiers, or it can carry 50 military tanks at the same time in a partially dismantled condition. So we are using it as a strategic transportation vehicle, and this is also referred as a great bison because of its shape. No, because of its appearance, it is called great bison. It is also called great bison. So C-7 Globemaster 3. C-7 Globemaster 3, India has incorporated it from US. India has incorporated it from US. Yes, Mirage 2000 is from France. Mirage 2000 is from France. So India has incorporated it from US. It is a fighter aircraft. It is a fighter aircraft. It is a fighter aircraft. But if India has to use it for fighting, it is a fighter aircraft, but if India has to use it for fighting, we need an NOC. We need an NOC, that is no objection certificate. We need an NOC, no objection certificate from US government. We require an NOC or no objection certificate from US government. Hence, we are using it as a strategic transportation vehicle. Hence, we are using it as a strategic transportation vehicle. Hence, we are using it as a strategic transportation vehicle. It can lift 2,500 soldiers. It can lift 2,500 soldiers. It can lift 2,500 soldiers in a single lift. In a single lift. It can lift 2,500 soldiers in a single lift. Or carry 50 military tanks. Or carry 50 military tanks. Carry 50 military tanks in a partially dismantled condition. In a partially dismantled condition. Can carry 50 military tanks in a partially dismantled condition. It is called Great Bison. It is called Great Bison. It is called Great Bison because of its charismatic appearance. It is called Great Bison because of its charismatic appearance. This C-17 Globemaster 3. So this is a 5th generation aircraft India is having, and we have incorporated it from USA. Okay. So these are the different generations of aircraft. So we have covered the topic of aircrafts. We discussed the different aircrafts, different generation of aircraft, different aircrafts India is having, etc. Now we will come back to the topic which we are discussing. What were we discussing? We were discussing about air-to-air missiles, right? We were discussing about air-to-air missiles, and we discussed one air-to-air missile called Astra. Okay, so while we were discussing Astra, I told you that this Astra is launched from Sukhoi 30 or Tejas, and in clubbing with that, we discussed the different generation of aircraft. Now, second air-to-air missile is K-100 missile. We have a second air-to-air missile called K-100 missile. Called K-100 missile. So if Astra was an indigenous missile, K-100 is a joint development of K-100. K-100. So this is the missile. Okay, this is the aircraft and it is getting launched from a missile. This is the missile. So K-100 is a joint development of India and Russia. India and Russia. Joint development of India and Russia. It is a medium range air-to-air missile. It is a medium range air-to-air missile. Astra was a short range missile. This is a medium range missile. Medium range air-to-air missile. Medium range air-to-air missile. Single stage solid propellant. Single stage solid propellant. Single stage solid propellant. And again, Sukhoi 30 will be preferred for launching the missile. We will prefer Sukhoi 30 for launching the missile. Sukhoi 30 is preferred for launching the missile. So K-100, this is another air-to-air missile we are having. K-100. So Sukhoi 30 will be preferred for launching the missile. So this is the K-100, medium range, joint development of India and Russia. So these are the major, two major air-to-air missiles India is having. Next is surface-to-air missiles. Surface-to-air missiles. Surface-to-air missiles. First surface-to-air missile is Akash. First surface-to-air missile is Akash. Akash. Akash is a medium range surface to air missile. It is a medium range surface to air missile. Akash is a medium range surface to air missile. It is the first missile to be developed under IGMDP. Akash is the first. We discussed the 5 types of missiles under IGMDP, right? So first one was Akash, if you remember. So Akash is the first missile under IGMDP. It is the first missile for under IGMDP. It is used for theater defense. It is used for theater defense. What is theater defense? Theater defense is war. No, we use it for wars. It is used for theater defense. And it is the first missile in India. It is the first missile in India to have ramjet engines. Ramjet engine. Theater defense means it is only used in battlefields. Okay, this Akash we use it only in the battlefields. For wars we use it. That is theater defense. So it is the first missile in India to have ramjet engines. It's the first missile in India to have ramjet engines. It's the first missile in India to have ramjet engines. So what is this ramjet engine? Ramjet engine is an engine which operates in the subsonic range. Ramjet engine operates in the subsonic range. An engine which operates in the subsonic range. Even though ramjet engine operates, you might have studied about ramjet engine in space. I'm not sure. So ramjet engine is a air breathing engine where you use air to fly this missile. You might have studied about it. So even this ramjet engine is a subsonic engine. It works less than speed of sound. But even then, Akash operates in the supersonic speed range. Even though this is a subsonic engine, Akash will operate in the supersonic speed. Akash will operate in the supersonic speed. Why this will operate in the supersonic speed? Because see, this is a low altitude missile. Because it is a cruise missile, it is a low altitude missile. Because of this low altitude, there will be always gravitational pull. Okay, there will be a gravitational pull. So even though the engine is a subsonic engine, it will achieve supersonic speed because there is gravitational pull, and with the assistance of this gravitational pull, it will be able to achieve this supersonic speed. So Akash will operate in supersonic speed as it is a low altitude missile. As it is a low altitude missile. As it is a low altitude missile. As it is a low altitude missile, due to the gravitational pull, as it is a low altitude missile, due to the gravitational pull, it will be able to achieve supersonic speed. It will be able to achieve supersonic speed. So Army and Air Force is using this Akash. Both Army and Air Force is using Akash. Even today, both Army and Air Force is using it. Army, Air Force. One more point is that Akash is an anti-cruise missile. Okay, it is a kind of anti-cruise missile. That is, it can be used to destroy cruise missile. Akash is a kind of anti-cruise missiles. It can be used to destroy cruise missiles. Okay, so this is one of the India's surface to air missiles, Akash. This is the testing of Akash 1S. So from surface it is launching. So air. So this is new version fitted with a seeker. I'll tell you what is a seeker. So in 2019 we tested this new version. So launch from surface, it will target something on the air. So surface to air missile. So they said it is fitted with the seeker. So So seeker is something which determines the accuracy of a missile. So when it is fitted with a seeker, it will improve the accuracy of the missile. That the technology of seeker is actually closely guarded. They have not revealed what is the technology behind the seeker. So seeker just means it determines the accuracy of the missile. So this Akash 1S, which we test fired in 2019, is fitted with a seeker which will improve the accuracy of this missile. So this, it is fitted with a seeker which will improve the accuracy of a missile. So this is the first surface to air missile. Now second surface to air missile is Trishul. 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 So Trishul is a short range surface to air missile. It's a short range surface to air missile. The range is between 9 to 12 kilometers. It's a short range surface to air missile. The range is between 9 to 12 kilometers. Range between 9 to 12 kilometers. And it has something called sea skimmer facility. Sea skimmer facility. It has a feature called sea skimmer facility. So what is the sea skimmer facility? It will fly very low to the surface, that is below 50 meters. So when it flies very low to the surface, it will be able to avoid this radar and detection. So this facility is called sea skimmer facility. It flies very close to the atmosphere, that is less than 50 meters, so that it will avoid the radar and the probability of being shot down. That is called a sea skimmer facility. So it flies very low. It flies very low. It flies very low, below 50 meters, in brackets below 50 meters. It flies very low to avoid detection, from radar, etc. To avoid detection from radar, etc. Which reduces the probability of being shot down. Which reduces the probability of being shot down. Which reduces the probability of being shot down. Now, Trishul is not in use now. We officially shut down Trishul in 2008. Not in use now. Trishul is not in use now. We officially shut it down in 2008. Not in use. We officially shut it down in 2008. Trishul. Trishul not in use. Short range surface to air missile. Currently not in operation. It has the sea skimmer facility. Sea skimmer facility, it can fly very close to the atmosphere. That is called sea skimmer facility. Now this Trishul was replaced by a missile called Maitri. Trishul was replaced by a missile called Maitri. Maitri is a short range quick response. QRSAM is quick response surface to air missile. Maitri is a quick short range missile. It is a short range missile. It is a QRSAM, quick response surface to air missile. Quick response surface to air missile. Quick response. So we discussed quick response. What is quick response? Here it can strike the target in 8 seconds. QRSAM, quick response, because it can strike the target in 8 seconds. Quick response surface to air missile. So this filled the gap with after Trishul. So this was kind of a replacement for Trishul, or it was a gap filling mission. It was a replacement for Trishul, or it was a gap filling mission. So this is actually, this we developed as, this is a joint development of India and France. Joint development of India and France. So two missiles. France had a missile named Mica and India had this Trishul. Okay, it is kind of a combination of both this. That is why the name Maitri. This is the missile of France, Mica, and we had Trishul. India had Trishul. So India and France together developed this. We are not able to see. So So Mica belongs to France and Thrissur belongs to India. So it is a joint development of India and France. So it is a short range, quick response surface to air missiles. Short range, quick response surface to air missile. Sorry, Maitri. Next is Spider. Next missile is Spider. So Spider we acquired from Israel. We acquired this missile from Israel. We acquired this missile from Israel, Spider. And it is also a quick response surface to air missile. It is also a quick response surface to air missile. Quick response surface to air missile. Quick response surface to air missile. It is a beyond visual range missile. Beyond visual range surface to air missile. It is beyond visual range surface to air missile. Beyond visual range surface to air missile. And Spider can be both short and medium range. It can be both short and medium range. It can be both short and medium range. Both short and medium range. How it can be both short and medium range at the same time? How it can be both short and medium range at the same time? Because this Spider consists of two missiles. Okay, we are launching two missiles simultaneously. So there are two missiles. First missile is called. So that we are launching two missiles simultaneously in Spider. So first missile is called Python. So first missile is called Python, and the second missile is called Derby. So we are launching two missiles simultaneously, Python and Derby. So this Python is a LOAL missile. So Python is an LOAL missile and Derby is an LOBL missile. So lock on, one is lock on after launch, other is lock on before launch. Two missiles are there. Spider consists of two missiles, Python and Derby. Okay, Python and Derby. Python is LOAL, Derby is LOBL. Python is LOAL, Derby is LOBL. So if you see this image, you can see at the same time there are two missiles which are getting launched. See, there are two missiles which are simultaneously being launched. So one is an LOBL and other is an LOAL. So it is a mix, both short range and medium range is possible. So acquired from Israel, quick response, beyond visual range, and the range is 15 kilometers. So the range is even lesser than Akash. Akash range is approximately 25 kilometers, but here the range is approximately 15 kilometers. In short range, the range is 15 kilometers lesser than Akash. So this is the Spider system. See, this is the launcher which is used to launch Spider. So at the same time, it's the same Rafale company. So Python and Derby missile systems, two missiles, they are getting launched from this, this missile launcher. This is the Derby. This is the Python missile. Python is LOAL, lock on after launch. This is Derby. This is a fire and forget missile. That is after it is LOBL. Again, details Mac and all is not read. Mac 4. Short range, medium range. It can be used for both. Okay, how it is launched? It is launched from a truck, blah blah. Surface to air, no? Not needed. Now, one more point you have to write is that the launcher, you saw the launcher, right? This launcher is 360-degree rotatable launcher. The launcher which is used to launch this spider is rotatable 360-degree. It's a 360-degree rotatable launcher. It's a 360-degree rotatable launcher. Degree. Video is stuck. Is it working? Okay now? Oh, you want one more break? Okay. So 5 minutes. We'll be back. I'll be back in 5 minutes. Okay. 5 minutes break you can take. We'll come back. See, among the missiles, Python has a range of 20 kilometer. Python is a short range missile, and Derby has a range of 50 kilometers. Okay, Derby is a medium range missile. Python has a range of 20 kilometers. Derby has a range of 50 kilometers. So here the Python is the short range missile. It is LOAL, and Derby is the LOBL, and it is a medium range missile. Now next surface to air missile is Barak 8. Barak 8. Barak 8. B-A-R-A-K. So Barak in Hebrew, it is a Hebrew word. So Barak in Hebrew means lightning. Barak in Hebrew means lightning. So this is a joint development of India and Israel. Barak is a joint development of India and Israel. And it is a long range surface to air missile. It's a long range surface to air missile. Barak is a long range surface to air missile. It is a long range surface to air missile. Barak is an anti-cruise missile. Barak is an anti-cruise missile. Barak is an anti-cruise missile. And it is capable of defending, any type of airborne threats. It is capable of defending any type of airborne threats. So be the airborne threat, be from an aircraft, or be it from a helicopter, be it from a missile, be it from a UAV, any types of airborne threat. See, bison, great bison is just a name which is given to this globe master. That is all. There is nothing because of its appearance. If you see the photo of this globe master, it has that a majestic look. So that is why it is called a great bison. That's all. You see the picture of a bison, and it has a majestic look. So that is why it is called a great bison. Just a name which is given to this globe master. That is all. So Barak 8, as discussing, is capable to defend any type of airborne threat. So from aircraft, helicopters, missiles, any kind of airborne threat, it is capable to defend. It is an anti-cruise missile, I told you, and it is the only missile that is capable to intercept BrahMos. This Barak 8 is the only missile. Barak 8 is the only missile capable to intercept BrahMos. BrahMos is the fastest supersonic cruise missile, and Barak 8 is the only anti-cruise missile for BrahMos. India is having both. Okay, India is having both. We are having the BrahMos, and we are having the Barak 8 also. So there is no other anti-cruise missile which is capable of intercepting BrahMos so far. So it is the only missile in the world which is capable of intercepting BrahMos. It is an anti-cruise missile. It has a multi-handler. That is, it can carry conventional weapons and conventional warhead and nuclear warhead at the same time. It can carry conventional warhead and nuclear warhead. It can carry conventional warhead and nuclear warhead at the same time. It can carry conventional warhead and nuclear warhead at the same time. That is, it is multi-handler. Then it is two-stage solid propellant. Barak 8 is two-stage solid propellant used by Indian Army and Navy. Two-stage solid propellant used by Indian Army and Navy. Two-stage solid propellant used by Indian Army and Navy. Used by Indian Army and Navy. Next, surface-to-surface missiles. Surface-to-surface missiles. used by Indian Army and Navy. See, this we told Barak is a long-range surface-to-air missile, but our army is using a medium-range surface-to-air missile. Okay, even though Barak is a long-range surface-to-air missile, our army is using a medium-range version of the same. Medium-range surface-to-air missile, our army is using. Next is surface-to-surface missile. First, we will discuss about Prithvi. Prithvi. So Prithvi is again a missile which is developed under IGMDP, our Integrated Guided Missile Development Program. We have developed this Prithvi. So Prithvi, first is Prithvi. So Prithvi has three versions: Prithvi 1, Prithvi 2, and Prithvi 3. Prithvi has three versions: Prithvi 1, Prithvi 2, and Prithvi 3. So Prithvi 1 is the army version of Prithvi. Prithvi 1 is the army version of Prithvi. Prithvi 1 is the army version of Prithvi. And it is currently not in operation. It is currently not in operation. The range of Prithvi 1 is around 150 kilometers. The range of Prithvi 1 is around 150 kilometers. Capable of carrying a warhead of 1000 kilogram. It is capable to carry a warhead of 1000 kilogram. Prithvi 1. And it is currently not in operation. Currently not in operation. Prithvi 1 currently not in operation. 1150 kilometer range, 1000 kilogram warhead. Currently not in operation. Prithvi 1 is actually replaced by a missile called Prahar. So Prithvi 1 is replaced by a missile called Prahar. Prithvi 1 is replaced by a missile called Prahar. See, all the Prithvi missiles are short range missiles. Okay, Prithvi 1, 2, 3, all of them are short range missiles. So in Prithvi, when we develop Prithvi or Prithvi range of missiles, we never went into medium, intermediate, long range. So only in Agni series, after Prithvi, we will be discussing the Agni series. So Agni will be having medium range, intermediate range, and long range. All the Prithvi missiles are short range missiles. These are all short range surface to surface missiles. So it is a common feature. So Prithvi 1 is a short range missile. You can write individually or together also. It is a short range surface to surface missile. Short range surface to surface missile. And when we say surface to surface, it is ballistic. These things you should understand by yourself. I will not repeat in each term because surface to surface, it is ballistic. Surface to surface meaning it is ballistic. And all these three are short range missiles. So it is short range surface to surface missile, which means it is a ballistic missile. It is an Prithvi 1 is the army version of the same. Prithvi 1 is an army version, around 150 kilometers a range. It is capable of carrying 1000 kilogram warhead. Currently not in use. It is replaced by Prahar. Prithvi 2 is the Air Force version. Prithvi 2 is the Air Force version. Prithvi 2 is the Air Force version. And again, it warhead is, it can carry a warhead somewhere between 500 to 1000 kilogram. It can carry a warhead of 500 to 1000 kilogram. It is India's first anti-ballistic missile. Prithvi 2 is India's first anti-ballistic missile. Prithvi 2 is India's first anti-ballistic missile. Prithvi 2 is India's first anti-ballistic missile. So again, short range, surface to surface missile, ballistic missile, all these things are the same. It is a short range missile, surface to surface missile, anti-ballistic missile, it is all same. And it uses single stage liquid propellant. Prithvi 2 uses single stage liquid propellant. Single stage liquid propellant. Range is somewhere between 250 to 350 kilometers. 250 to 350 kilometers is the range of Prithvi 2. 250 to 350 kilometers is the range of Prithvi 2. Now Prithvi 3 is the naval version or the version of Navy. Prithvi 3. Prithvi 3 is the naval version. Is the naval version. Range approximately 350-kilometer range, same as Prithvi 2. Warhead of 1000 kilogram. 350-kilometer range, warhead of 1000 kilogram. Prithvi 3 is also a ship-to-ship missile. Is also a ship-to-ship missile. What is a ship-to-ship missile? It is launched from a ship and it is used to destroy another ship. That is why it is a ship-to-ship missile. So it is a naval version. So it is launched from a ship. It is used to destroy another ship. Launched from a ship, used to destroy another ship. That is why it is a ship-to-ship missile. Ship-to-ship missile, and it uses two-stage solid propellant. Two-stage solid propellant. It uses two-stage solid propellant. Now Prithvi 3 is now not in use. This is not in use. We have replaced Prithvi 3 with another missile called Dhanush. So this is the version we are using now, Dhanush. Prithvi 3. The modified version is called Dhanush. Dhanush. We are using Dhanush now. So the difference between Prithvi 3 and Dhanush is Prithvi 3 is a two-stage solid propellant, but here in Dhanush we have solid and liquid propellant. Two-stage solid plus liquid propellant. So this is the difference. Solid propellant plus liquid propellant. This is Dhanush. This is Dhanush. So we are using Dhanush now. This is the modified version of Prithvi 3. Okay. And again, we just said that Prithvi 1 is not in use, but rather we are using something called Prahar. So this is the version which is used by army now, Prahar. So what is the meaning of Prahar in Hindi? Prahar means strike. Okay. So the meaning here is strike. Meaning of the word is strike. Prahar. Again, it is a short range surface to surface ballistic missile. Short range surface to surface ballistic missile. Replacement of Prithvi 1. Replacement of Prithvi 1. It is solid fueled. Solid fueled. Or it uses solid propellant. Single stage solid propellant. And it is also a quick response missile. Quick response surface to surface missile. It's a quick response surface to surface missile. Fine, this is about the Prithvi series. So we discussed Prithvi 1, 2 and 3. We discussed about Prahar, which is a replacement of Prithvi 1. And then we discussed the modified version of Prithvi 3 called Dhanush. So this is about the Prithvi missiles. So you can see it is a tactical surface to surface short range missile. So what we discussed, what is tactical? Tactical is, what is the meaning of tactical? In terminologies we have discussed is, there is high precision and accuracy. These missiles have high precision and accuracy. So tactical surface to surface missiles, it can carry nuclear warheads, naval variant Dhanush, 3 variants, all we discussed. You can just see a video of Prithvi. So India fires supersonic Prithvi 2 missiles. So this is Prithvi 2. Prithvi 2 is the version used by the Air Force. This is the test firing video. A different version, same thing, Prithvi. Now, after Prithvi, we started developing the Agni series, Agni missiles. After Prithvi, we started developing the Agni missiles. Agni missiles. So, Agni, we have a series of 6 missiles. Agni 1 to 6 is there. 1, 2, 3, 4, 5, 6. So, Agni 1 to 4 is currently in operation. 5 is in the testing phase and 6 is in the planning stage. So, there are 6 versions of Agni. Agni 1, 2, 3, 4, 6, out of which 1 to 4 is currently in operation. All this is being used. Agni 5 is in the testing phase. Agni 6 is only in the developmental phase. We are only developing it. Developmental phase, testing, etc. has not started. This is in the development phase. Now, Agni 1 to 3 was developed under IGMDP. Integrated Guided Missile Development Program. We developed till Agni 3. Okay, till Agni 3, it was developed under IGMDP. Agni 4 and 5 is not developed under IGMDP. Okay, Agni 4 and 5 is not developed under IGMDP. Now we'll discuss each of them one by one. First is Agni 1. Agni 1. So Agni 1 is the only missile in Agni which is medium range. Okay, so Agni 1 is the only missile in Agni which is medium range, and it is also called a bridge missile. It is also called a bridge missile. All the Agni missiles are used by Indian Army. Okay, all the Agni missiles are used by certain things. All the Agni missiles are used by Indian Army. All the Agni missiles are surface to surface missiles. That means all the Agni missiles are ballistic. Okay, all the Agni missiles are surface to surface. That is, they are ballistic. All the Agni missiles are used by Indian Army. Now the range of these Agni missiles will vary. So the first one is Agni 1. Agni 1 is a medium range surface to surface missile, the only medium range missile in the Agni series. It is called a bridge missile. It is called a bridge missile. As it acts as a bridge between. It is called a bridge missile as it acts as a bridge between the short range Prithvi 3. Okay, it acts as a bridge between the short range missile and intermediate range missile, right? Short range and the intermediate, it acts as a bridge. So short range, we have Prithvi 3, or the Prithvi series is a short range missile, and then intermediate range starts from Agni 2. Agni 2 is an intermediate range missile. So this Agni 1 acts as a bridge between Prithvi 3 and Agni 2. It acts as a bridge between short range and intermediate range. So this is called a bridge missile. Single stage solid propellant. Single stage solid propellant. It is fired from a static platform. This is fired from a static platform. So we cannot fire Agni from a moving platform. That is, if you want to fire it from a military tank, not possible. Moving submarine, not possible. It has to be fired from a static platform. Agni 1 has to be fired from a static platform. So it can fire either conventional or nuclear. It is a nuclear missile, but it is a nuclear missile. But at one time it can fire only either conventional or nuclear. It is not able to deal both. It can fire either conventional or nuclear warhead. It can carry either conventional warhead or nuclear warhead at one time. So if we take Agni 1, the range is somewhere between 700 to 1200 kilometers. So Agni 1 range is between 700 to 1200 kilometers. And warhead is around 1000 kilogram. 1000 kilogram warhead it is capable to carry. So this is Agni 1. Now next is Agni 2. Agni 2. So Agni 2, as I told, it is an intermediate range ballistic missile. Agni 2 is an intermediate range ballistic missile. Again, this is capable of carrying either conventional warhead or nuclear warhead, not both. Either conventional or nuclear. It cannot carry both, either conventional or nuclear. Either conventional or nuclear. It can be fired from dynamic targets also. Dynamic platforms. It can be fired from dynamic platforms. Like moving trucks, etc. You can fire it. It can be fired from dynamic platforms. Two-stage solid propellant. Two-stage solid propellant. Agni 2 is two-stage solid propellant. Range is between 2000 to 3000 kilometers. Range is between 2000 to 3000 kilometers. So when 2000 to 3000 kilometers means it can cover Pakistan, Afghanistan, and Kazakhstan. Agni 2 can cover. So if you are launching the missile from Delhi, it can cover Pakistan, Afghanistan, Kazakhstan. Up to Kazakhstan it can reach. Up to Kazakhstan it can reach. So it is a credible deterrence against Pakistan. So Pakistan can be easily targeted with Agni 2. Now next is Agni 3. Agni 3. Agni 3 is also an intermediate range surface to surface missile. Intermediate range surface to surface missile. Intermediate range surface to surface missile. Two-stage solid propellant. Two-stage solid propellant. Two-stage solid propellant. Either conventional or nuclear. Either conventional or nuclear. Either conventional or nuclear. Can be launched from dynamic platforms. Can be launched from dynamic platforms. Range is between 3500 to 5000 kilometers. Range is between 3500 to 5000 kilometers. So Agni 2 could cover ranges between 3,500 to 5,000 kilometers. So Agni 2 could cover Pakistan, Afghanistan, and Kazakhstan. So this Agni 3 can cover, southern part of China also. Southern and southeastern China can be covered. Southern China and southeast China will be reached with Agni 3. Southern China and southeast China will be reached with Agni 3. See, all Agni missiles are surface to surface missiles. All Agni missiles are surface to surface missiles. Agni, Prithvi, and Prithvi are indigenous. So, if at all there is any collaboration, I'll specifically mention that it is a what we say collaboration project. And Prithvi 2 uses single stage liquid propellant. Yes, it uses a single stage liquid propellant. Okay. So now Agni 3 we discussed it. The distance is between 3,000 to 5,000. It is an intermediate range missile. It can reach up to China. Some parts of China it will be able to reach. Next is Agni 4. Agni 4. So as I told, Agni 4 was not developed under IGMDP. It was developed outside of IGMDP. And Agni 4, the mission head was someone else. Do you know the mission head of Agni 4? She's called the Missile Woman of India now. Missile Woman of India. Any idea? What is her name? The Missile Woman of India. Have you heard about the Missile Woman of India? No. Tessie Thomas. So Tessie Thomas is heading both Agni 4 and 5. Agni 4 and 5. Okay. See, she is in head of this Agni 4 and Agni 5 also. She's heading. Okay. She's heading. She's the mission project director of Agni 4 and 5. Now Agni 4 is also an intermediate surface to surface missile. Agni 4 is intermediate surface to surface missile. Two-stage solid missile. Two-stage solid propellant. Two-stage solid propellant, but it can carry both conventional and nuclear warheads. At the same time, it can carry conventional and nuclear warheads. At the same time, it can carry conventional and nuclear warheads. Can be fired from dynamic platforms. It can be fired from dynamic platforms. Agni 4 act as a bridge between medium range missiles and long range missiles or intercontinental missiles. It acts as a bridge between medium range and long range missiles, ICBM. So Agni 4 is a modified version of Agni 2. Agni 4 is a modified version of Agni 2. Agni 2 has one more version called Agni 2 Prime. Some modifications they made in Agni 2 and made something called Agni 2 Prime. So this Agni 4 is actually a modified version of this Agni 2. Agni 4 is a modified version of Agni 2. And Agni 4 has its own navigational system for guidance. It has its own navigational system for guidance. It has its own navigational system for guidance, which is called RINS navigational system. RINS navigational system. So this RINS is based on a navigational system called INS, inertial navigation system. This is based on this inertial navigation system. So what is this inertial navigation system? So inertial navigation system. So inertial navigation system uses a computer. It uses a computer, motion sensors. It has a computer. So it will sense, it is a navigation system. That means it can sense the direction by itself. So what all it is using? It has a computer, then it has motion sensors. It has motion sensors. This motion sensor is called accelerometer. It has motion sensors called accelerometers. And it has rotation sensors. It has rotation sensors called gyroscopes. It has rotation sensors called gyroscopes. So this Agni 5 has its own navigation system called RINS. RINS is a type of inertial navigation system. So in inertial navigation system, we have a computer, we have motion sensor, and we have rotation sensor. It can calculate the position, orientation, and velocity of the moving object. Using this inertial navigation system, we can calculate the position orientation. And velocity of moving object. We can calculate the position, orientation, and velocity of moving object. So we will be able to navigate it using this system, inertial navigation system. We will be able to navigate Agni 4 using inertial. So RINS is a type of inertial navigation system. RINS is a type of inertial navigation system. Ring laser. So this is ring laser gyroscope inertial navigation system. This is a type of inertial navigation system. Just remember this uses RINS. This gyroscope, there are some features. It uses a ring laser gyroscope, etc. So RINS is the ring laser gyroscope inertial navigation system. Again, by using this navigation system, you can maneuver this Agni in a very precise manner. That is the use of this navigation system. It uses RINS navigation system. It uses ring navigation system. Range is again somewhere between 2,500 to 3,500 kilometers. Range is 2,500 to 3,500 kilometers. And it can see 2,500 to 3,500 kilometers means it can target some hotspots in China. It can target some hotspots in China. Hotspot is very commercial places in China. Hotspots is very business commercial places in China where there is a lot of people, etc. So this is called hotspots. No, Chennai is a hotspot. Bangalore is a hotspot. Delhi is a hotspot where there is a lot of commercial business activities. So if somebody wants to strike us, if they target any of this hotspot, there will be massive disaster or massive attack can be launched. So Agni 4 can target hotspots in China. Can target some hotspots in China. It is a two-stage solid propellant. Two-stage solid propellant. I think I told you in the beginning itself. Two-stage solid propellant. So this is Agni 4, two-stage solid propellant. Next is Agni 5. Agni 5. Agni 5 is intercontinental ballistic missiles. Intercontinental ballistic missiles. It is the first intercontinental ballistic missile. Okay, it is the first intercontinental ballistic missile. Three-stage solid propellant. Three-stage solid propellant. It has RINS system. RINS system, that is ring laser gyroscope, inertial navigation system. It has a ring system. Which one? Agni 1, Agni 1 is medium. Agni 2, 3 and 4. I'm just answering the doubts. Agni 1 is medium. Agni 2, 3 and 4 is intermediate. And Agni 5 is long range. Agni 5 is long range. Agni 5 is long range. So it has a ring system capable of carrying both conventional and nuclear warheads. Capable of carrying both conventional and nuclear warheads. Capable of carrying both conventional and nuclear warheads. It has something called MIRV. It has a feature called MIRV. What is MIRV? Multiple independent re-entry vehicle. Multiple independent re-entry vehicle. Multiple independent re-entry vehicle. So multiple independent re-entry vehicle means at the same time it can target different locations. Okay, multiple. So it is carrying both nuclear warhead. It can simultaneously carry nuclear warhead and conventional warhead. So at the same time it can strike different locations simultaneously. That is the meaning of multiple independent re-entry vehicle. So it is not just one target. At the same time you can target different locations. So that is why it is called multiple independent re-entry vehicle. Multiple independent re-entry vehicle. It has anti-satellite missile capacity. It has anti-satellite missile capacity. It is even capable of destroying satellites. It has anti-satellite missile capacity. It has anti-satellite missile capacity. It is capable of performing. It is capable of performing canister launch. It is capable of performing canister launch. It is capable of performing canister launch. Now, what is this canister launch? Canister is a kind of cylindrical tube. Canister is a kind of cylindrical tube. Canister is a cylindrical tube. Now, by providing this or by putting this missile in a canister, there are two purposes which can be achieved. Okay, one, this canister will act as a protective environment. You put this missile in a canister, canister will act as a protective environment, and it can be used as a launch pad for missiles. So there is something called canister launch. We'll discuss. There are two types of canister launches: hot canister and cold canister. Hot canister and cold canister launch is there. So what is this canister? Canister is nothing but a cylindrical tube. So it acts as a protective environment for the missiles. It acts as a protective environment for the missiles, as well as a launch pad. As well as a launch pad. So like, no, this is a cylinder, there is a cylindrical tube, and you will put this missile inside the cylindrical tube. This is the canister launch. So it will be kept inside a cylindrical tube. So this is canister launch. There are two types of canister launches. There are two types of canister launches: hot canister and cold canister. Hot canister and cold canister. Hot canister or cold canister. In hot canister launch, the missile will ignite. The missile will ignite inside the cell or inside the canister itself. the missile will ignite inside the cell. In hot canister, the missile will ignite inside the cell. And in cold canister, the missile will be first expelled from the canister. The missile will be first expelled from the canister and then ignited. See, what is the problem of this hot canister launches? See, when the missile is igniting, it will produce lot of heat, right? It will produce lot of heat. So that is dangerous. So if at all anything goes wrong, that it is inside a canister, and hot canister launch. At times, when if you want to launch a long range missile, etc., you need lot of thrust. So it can be dangerous to the canister. So we use this hot canister launch. We use hot canister launch for short range and medium range missiles. We use hot canister launch for short range and medium range missiles. We use hot canister launch for short range and medium range missiles. So this hot canister launch is used for missiles like BrahMos. Now for BrahMos we use hot canister missiles. For missiles like BrahMos we use hot canister missiles. Cold canister launch is preferred for long range missiles. Cold canister launch is preferred for long range missiles. So in Agni 5 we go for cold canister launch. Agni 5 uses cold canister launch. So it is put inside a cylindrical canister. Then we are going to launch it. First it will be pushed out of this canister and then it will be ignited. First it will be pushed out, then it will be ignited. But it provides a canister because it will provide a safe environment, because you never know when this missile is going to be launched, and then if it is kept for a long time in the atmosphere, there can be damages to the part of the missile. So we will keep it inside a cylinder and then it is capable of being launched from a canister. So first it has to be pushed out, then it will be ignited. So this is the canister launch. So Agni 5, and the range of Agni 5 is between 5,000 to 7,500 kilometers. The range can vary between 5,000 to 7,500 kilometers. Range 5,000 to 7,500 kilometers. It can cover half of the globe. It can cover half of the globe with this range. It can cover half of the globe, and hence it is called a killer missile. It's called a killer missile. Is called a killer missile. So this is regarding Agni 5. Agni 5 is more advanced. Now we have Agni 6. Agni 5 is in the testing stages. We have Agni 6. Agni 6 is in the developmental stage. Agni 6 is in the developmental stage. It also will be an intercontinental ballistic missile. Intercontinental ballistic missile. It will be an intercontinental ballistic missile. 4-stage solid propellant. 4-stage solid propellant. Four-stage solid propellant. It has the RINS, inertial navigation system. Ring laser, gyroscope, inertial navigation system will be there. Multiple independent re-entry vehicle will be there, MIRV. And it also has something called MARV. It will have maneuverable re-entry vehicle. Maneuverable re-entry vehicle. It will have a feature of maneuverable re-entry vehicle. What is maneuverable re-entry vehicle? That is, the target can be changed even in the re-entry phase. So maneuverable means you are going to strike and you want to change the target, you can change the target. So this is maneuverable re-entry vehicle. Even as you are going to strike, you can change the target and the target location. So maneuverable, this Agni 6 will have MARV. That is maneuverable re-entry vehicle. Agni 6 will be maneuverable re-entry vehicle. That is, target can be changed. Target can be changed even in the re-entry phase. Even in the re-entry phase. It also will have canister launch capability. It has canister launch capability. It will have canister launch capability. The range is expected to be between 10,000 to 13,000 kilometers. The range is expected to be between 10,000 to 13,000 kilometers. Range is expected to be between 10,000 to 30,000 kilometers. So this is the Agni series which we have developed, Agni missiles. Discussed first intercontinental surface to surface missile, range of 5,000 kilometer, warhead 1,500 kilogram, fire and forget. Yes, Agni 5 is fire and forget. That is LOBL. Agni 5 is LOBL. This is one video of Agni 5. So test firing of Agni 5. So we are launching this intercontinental ballistic missile. So just the testing video is there. Next, we'll discuss submarine launched ballistic missiles. Submarine launched ballistic missiles. SLBM, submarine launched ballistic missiles. So we discussed in the beginning that DRDO has taken up a project to develop submarine launched ballistic missile. What was its name? Now, if you remember, I told you that currently DRDO is focusing on two missions. One was, you want me to explain MIRV or MARV? So there are two things. One is MIRV and the second is MARV. MIRV is there, MARV is there. So MIRV is multiple independent re-entry vehicle. Okay. At the same time, you are able to target different locations. A, B, C. You are targeting 3 locations at the same time. This is multiple independent re-entry vehicle. At the same time, you are targeting different locations because it is capable to carry both conventional and nuclear warhead. You can strike more than one location at a time. That is multiple independent re-entry vehicle. Now, maneuverable re-entry vehicles, initially you are planning to strike A. Now, as you are re-entering, you change the target to B. You change the target to B. This is maneuverable re-entry vehicle. You can change the location even when you are re-entering. Even when you are re-entering, you can change the location. This is maneuverable re-entry vehicle. Yes, Project Black. We discussed about Project Black. DRDO is trying to develop this submarine launch ballistic vehicles. So SLBM, missiles launched from submarines. SLBM is missiles launched from submarines. Missiles launched from submarines. So again, this SLBM is different from torpedoes. Don't confuse it with torpedoes. Torpedo, the entire movement will be underwater. Okay, a torpedo, the entire movement will be underwater. India has one torpedo. Do you know the name of India's torpedo? The name of India's torpedo, which was a UPSC prelims question. India's torpedoes, they gave the name and asked what it is. The other way around they asked. Any idea about the name of India's torpedo? Anybody? Varunastra. India's torpedo is called Varunastra. Varunastra. So Varunastra is India's torpedo. Anyway, this is different from submarine launch ballistic missile. So ballistic missile, all these phrases are there. From submarine, it will come out of water, atmosphere, outer space, then it will come and reach the other side. So this is only the way in which the submarine launch ballistic missiles will work function. So it needs to come outside the water. It needs to come outside the water and make a re-entry into the land. And make a re-entry into the land. So we have a nuclear submarine. So to launch this submarine-based ballistic vehicle, we should have submarines, right? So India has an indigenous nuclear submarine. Do you know the name? We'll discuss about it later in the submarines. We have a class of submarines called Arihant. So we have a class of submarines, indigenously developed class of submarines called Arihant. We have a class of submarines called Aryan. So all SLBMs, submarine launch ballistic vehicles, all SLBMs can be fired. All SLBMs can be fired from Arihant submarine. All SLBMs can be fired from Arihant submarine, which is India's indigenous nuclear submarine. Which is India's indigenous nuclear submarine. Which is India's indigenous nuclear submarine. Now we are going to discuss this indigenous nuclear submarine. The name of, we are going to discuss this submarine launched ballistic missiles. So all these missiles are modified versions of Agni family. All these missiles are modified versions of Agni family. See, Sagariga, K4, K5, we'll discuss this. These are modified versions of Agni family. And all of them can carry nuclear warheads. All of them can carry nuclear warheads. Even all Agni missiles could carry nuclear warheads. If you remember, Agni 1 I told, it can carry either conventional or nuclear. Okay, that means it is nuclear capable. It can carry nuclear warhead. Here also, all these ballistic missiles can carry nuclear warheads. All these missiles can carry nuclear warheads. All Agni missiles was with Army. All these SLBMs is with Navy. All this submarine launched ballistic missile is with Navy. It is Indian Navy's property. It is Indian Navy's property. So the first submarine launched ballistic missile is called K-15 or Sagariga. It is Sagariga, first one, K-15 or Sagariga. It is a medium range SLBM. Medium range SLBM. SLBM is submarine launched ballistic missile. Just write SLBM. That is enough. Now, if I write MRSLBM, you should be able to understand what it is. MRSLBM, Sagariga. Medium range surface submarine launch ballistic vehicles. Two-stage solid propellant. This is a modified version of Agni 1. This is a modified version of Agni 1. Modified version of Agni 1. It operates in the hypersonic range. It operates in the hypersonic range. Modified version of Agni 1, and it operates in the hypersonic range. Nuclear capable. I told you in common. All these missiles are nuclear capable. So K-15 is also nuclear capable. Or Sagariga is also nuclear capable. Sagariga is also nuclear capable. It has a range of 750 kilometers. 750 kilometers. Range is 750 kilometers. So it is a medium range. If you remember, Agni 1 was also medium range, right? Agni 1 was also medium range. So Sagariga is also a medium range missile, 750 kilometers. This is the range of Sagariga, K-15. Now second, K4. K4. So this K actually represents Kalam. Okay, Kalam series. It is called Kalam series. That is what K represents. In memory of Abdul Kalam, we have represented it K Kalam series. And in K4 series, there are two missiles. In K4 series, there are two missiles. First one is MK1. MK1. This is in the testing phase now. MK1 is in the testing phase. It is in the testing phase. It is an intermediate range submarine launch ballistic missile. It is intermediate range submarine launch ballistic missile. It is a modified version of Agni 3. It is a modified version of Agni 3. So if you remember, Agni 3 was also intermediate range. This is also intermediate range. It is a modified version of Agni 3. MK1, intermediate range SLBM, two-stage solid. Two-stage solid propellant. Now MK2 is there. MK2. It is in the developmental phase. We have not started testing. It is in the development phase. It is in the development phase. It is a modified version of Agni 5. It is a modified version of Agni 5. So when it is a modified version of Agni 5, what will be its range? When it is a modified version of Agni 5, it will be intercontinental. It will be intercontinental. When it is a modified version of Agni 5, it will be intercontinental. Intercontinental. And it is three-stage solid plus liquid. So two stages solid and one stage liquid. It is three-stage, two-stage solid and one-stage liquid. So this is the K4 series. Okay, this is a K4 series. Now we have K5 series. K5 series. K5 series, which is the modified version of Agni 6. Which is the modified version of Agni 6. K5 series, which is the modified version of Agni 6. Four-stage solid. Four-stage solid. Four-stage solid. It is only in the planning stage. It is only in the planning stage. So this is the launch of Sagarika. So if we, as you can see, it is launched. It is getting launched from submarine. Underwater, it is getting launched. Okay, so we'll end today's discussion with this. You can just write the heading of the next topic. Next topic we'll be discussing will be anti-tank missiles. We'll discuss this in next class. Anti-tank missiles. Anti-tank missiles. So now after this we'll go to the cruise missiles, BrahMos, etc. We'll discuss. Then we'll discuss the then we'll go to this anti-ballistic missiles detail. So we have two types of anti-ballistic missiles that will be discussed. Then after that we'll go to the patrolling system and surveillance system. So with that we'll come to the end of defense topics. So any questions? So science and technology, it's more, there are some things which you have to understand and some things is factual. So both has to be mixed. Some technology they can ask, canister launch, you should know, MIRV kind of technology. These things you should know. But then whether it is single stage, two stage, all these things is factual information. So that you have to remember. Okay, my mail ID is arjun.kr@shankaris.in. This is my mail ID. arjun.kr@shankaris.in. Fine. Any questions? No, no, ballistic missile will never be surface to air missiles. Okay, ballistic missile can be only surface to air if it is an anti-ballistic missile. Unless otherwise, ballistic missiles will be surface to surface only. No, it is not showing the striking part. That is all. In the videos, they are only showing the launching of it. That is why it is looks like it is going to the air. Obviously, it will go to the air and then it will go to the upper outer space and then it will strike something on the surface only. Right. So all ballistic missiles are surface to surface. No, no. See, Agni 4 is a is connects Agni 4 connects. No, it is a bridge between medium and long range. Agni 4 is an intermediate missile. Okay, Agni 4 is an intermediate missile. Agni 5 is a long range missile. So it connects medium and long range. So intermediate comes between medium and long range, right? So it is a connect between medium and long range. So that is why it is a bridge between medium and long range. Not medium and intermediate. Agni 4 is intermediate. Any other questions? Thank you. Yes, yes. While testing missiles, we will have to test it against our own aircraft, our own ships, etc. So we will be using them only while testing this. That is correct. So basically, we have to test the missiles. We test these missiles from the Odisha coast. If you read the news, we have an island there called Wheeler Island. So there is an island called Wheeler Island, which is also now called the Kalam Island. Okay, so we are testing all our missiles from this region, Wheeler Island or Kalam Island. So again, we have to use our own equipments to test this. Submarine, yes, yes. Submarine launch ballistic vehicles is all indigenous. If at all there is any projects where we are collaborating, that would be specifically mentioned. Unless otherwise mentioned, all projects are indigenous. So if at all there is collaboration, we'll definitely tell about the collaboration. Any other questions? Thank you so much. If no other questions, we'll end the class, today's class. Thank you. If you have